આજે 21 વર્ષનો 18 વર્ષનો પછી જોઈ લેવાનું કયા ખોટા થઈ ગયા. આ 21 વર્ષનો 18 વર્ષનો પછી આમાં જો ડાબી બાજુએ ચાલવાનું ઉપર વગરનો રોડ હોય બરોબર આવી રીતે પ્રેક્ટિસ કરી લેવાનું.
Good morning, sir and ma'am. Sir, you are on mute, sir.
Okay. Namaskar.
Yes, sir. Good morning, sir. Namaskar.
Good morning.
Good morning, ma'am.
Good morning. How are you?
All well, ma'am. How are you?
Yeah, I'm fine. We are ready. Whenever you say, we'll start.
Ma'am, I just... Yes, ma'am. So,
Yeah,
ma'am,
yeah.
we'll start in 2 minutes, ma'am.
Yeah, no issue.
No issue.
તમારો આ બસ અમારે આવશે. બધાયના આવી ગયા ડિપ્લોમા બાકી ડિપ્લોમાના બધાયને બાકી વાજે
So a very good morning to everyone. It's time to start the day 4 of this short-term training program on water quality complication, restoration and environmental conservation of existing water bodies that is sponsored by AICTE and organized by the Civil Engineering Department of IPS Academy, Institute of Engineering and Sciences, Indore. Today the first session will be taken in combination by Dr. Swati Samvatsar and Engineer Milind Pandit, sir. Dr. Swati Samvatsar is a director of JalaSRI Watershed Surveillance and Research Institute, Jalgaon, Maharashtra. She is postgraduate, doctorate, DEM, fellow of ethnobotany, with 30 years of professional expertise as development professional in various organizations at different positions like Chief Program Manager, State Head Rajasthan for Lupin Human Welfare and Research Foundation, Bharatpur, Rajasthan, CSR of Lupin Pharmaceuticals for Rural Development, Senior Executive and Tata Fellow in NM Sadhguru Water and Development Foundation, Dahod, Senior Program Officer in Foundation of Ecological Security, Anand. Her core competencies are research, administration, management, training, monitoring and evaluation, fundraising, impact assessment, documentation, process documentation, and so on. She has publications and numerous studies like 3 books, 15 scientific research papers, 28 studies, microplan for 1 district, 3 impact assessment, 9 vulnerability assessments of watershed areas. Along with her, I would also like to introduce Milind Pandit, sir. He is the director of NRM, Rajputana Society of Natural History, Alirajpur, developmental engineer for watershed development work, water resource structures and sanitation blocks. He is a civil engineer with professional expertise of 30 years, presently working on locations like Narmada, Chambal, Lower Yamuna, Mahi, Tapi River basins in Madhya Pradesh and Rajasthan, rival of Sukhat River, Bamani, tributary of Parvati, and so on. He is an active agriculturalist with 5 projects awarded by Kapat GOI, NABARD, Gujarat. He is also a faculty trainer for natural resource management, watershed area development, greenhouse technology, tradition and modern rain harvesting structures at Sadhguru Training Institute, Dahod, Gujarat, and also at Valmi Bhopal and Triple T RI, Chandigarh. Faculty member at BOC in Agriculture and Greenhouse Technology, which is a skill-based education funded by UGC at MJ College, Jalgaon, Maharashtra. A technical member of AICTE Advisory Committee for Sansad Adarsh Gram Yojana for Maharashtra State. He has trained 446 CEOs of Jila Panchayat and Janpad Panchayat from all over the districts of MP on watershed area development under IWMP program of Madhya Pradesh. A member of IUCN, IWA, UNCCD as development engineer for rural housing and electrification, women empowerment through skill development, microfinance, designing and implementation of drip irrigation system for optimal use of water in farm fields for growing vegetables and fruits, use of micro irrigation with plastic mulch for more than 2,500 plots, development of fish hatchery, which is a Chinese circular model for sweet water inland. He has also worked on projects like the financial inclusion with SWBJ in 4 districts of Rajasthan, design and construction establishment of low-cost backyard poultry sheds, establishment of low-cost hydroponic unit for fodder and vegetables, construction of biogas stationary dome, establishment of milk cooperatives with commissioning of bulk milk coolers, working on climate change adaptation series strategies for dry lands, and he also participates in national and international workshops regarding that. And he is also an independent evaluator of watershed at national and international level. I thank you so much, sir and ma'am, for devoting your time for us. And we are indeed honored to have you with us today. And I request you to please start with the presentation, ma'am and sir.
Just a minute. Is it visible? Presentation.
Ma'am, I can see you not your presentation yet.
Okay.
Yes, ma'am, it's visible now.
Okay, thank you.
Thank you, ma'am.
So, namaskar, and thanks a lot for such a kind and humble introduction. We are development professional, and if I can explain myself in one word, that I am a scientist now turned to be a social scientist. We are working for water-centric rural development, and whatever I am just sharing with you all is our experience of last 30 years and how we have worked and to where we have reached. So this is about this. So this is the dryland can be dreamland and experience with farmers of dryland located in different pockets of India. Me and Milind both of us working on this project, not this project, it's like program with our team and with using different platforms like Sadhguru Foundation, FPS, then LHWRF, even JalaSRI, and our own organization that is Rajputana Society of Natural History. Our presentation will be in 2 parts. First part I'll take care of, and the second part will be taken care by the Milind sir. In first part, we'll see what is dryland and what are the roadmap to reach the dreamlands. So, in when we learn the management skills, we always deal with the all W's and 1 H. So I'll deal with the all W and Milind will deal with the 1H. Means I'll deal what, where, with whom, and Milind sir will deal with how. So the technical aspect, how it happens, he will take care of. So what is dryland? When we want to be in the dryland or we want to change something about in dryland, so we need some following things, like we should know where we are, we should have all the information, then some good planning, good vision, and some good policies. Then mix it up, have, ask for some financial support from different organizations. Then canvas is yours. Then you can draw anything. Then it will create a harmony and it will be on the path of the dreamland. So in emojis, because I suppose we are having some student with us, so we should teach in their point of view. So now this is the time of emojis. So we start with the crying emoji and we end up with the smiling emoji. Coming to the our main program, we are having so many of natural resources. Everyone is aware that sunlight, atmosphere, land, air, water, vegetation, and animals and humans. But what we learn, not necessarily we internalize it. So problem is there. And when we work for the conservation of natural resource, we are knowing that the water is there, land, forests, cattle, fauna, people, everyone is there. But the reality is this: we are in such a huge number. We are occupying most of the niches, and every natural resources are decreasing. And we just thought we are the boss of this ecosystem. We forget that we are the part of this ecosystem. We can deliver n number of lectures, n number of symposia are going on, but really do we care of our natural resource? And where is the forest? Forest land is there, but the forest in real sense, we are missing it. Although nowadays we are increasing the forest land with some sparse density of plants, but in many areas, like you are sitting in Indore, and Indore is part of Malwa, and I also belong to Indore, and I remember my childhood days. In summer, we used to sleep on our open chat, and by 12 or 1 in the early in the morning, we need to have a rajai. Now we are using AC. So what we are losing and what we are getting? It's the main question. Are we using our whole lands? No, we are not smart enough. In India, erosion rate is too high. There are several reasons for the erosion. It may be wind erosion, it may be barren rock erosion, maybe because of salination. On other part, maybe because of water logging. Some is because of water erosion also. So every year, 147 million hectares of land is eroded. And are you aware? In our country, we are having marginal farmers in the highest number. So we can say empirically, every year 147 million marginal farmers are getting affected. You should think on this point. Then do we care our rivers? This picture is from our holy Ganga. Holy Ganga, where is the holiness? We always say कि गंगा हमारी माता है and हम उसको पूजते हैं. Is it the way to pray her? Still she is blessing us. I got one small a picture or drawing from net. I don't know who drew this, but very correctly drawn by a small kid. Again, think. Nowadays, Indore is becoming so clean and rivers are getting shape. But who will care for all this river? Although we are doing some attain, but the rate is so slow. And where is the surface water? When you are sitting in a metro like Indore, if I ask the school children from where we get the water, usually answer is that नल से आता है, या और भी बात करें तो दे सेड कि बिस्लरी की बॉटल में आता है, but the where is the source? And this is a real picture taken by me just 28 years back. The negative aspect is that the surface water is run away. But the positive aspect is that this tribal lady is aware where is the water. So when we deal with the conservation of natural resources, the role of indigenous people is very important. Then another picture again from the Jhabbar district. Is it potable water? You can see two human beings and two cattle. They are drinking from the same pond. This is another picture, but this is positive aspect. When we did the water conservation or we harvest the rainwater, these small outlets come out. And this again tribal lady from the same district, she is fetching the fresh and very sweet water. How it happens? And we always said that we are the blue planet. We are just a very small creature or small portion having in this big universe. But the positive aspect that we are the blue planets means we are having the life. Just respect it. I taught this in class 3 section also. Now come to the point how the water is distributed. Everyone is aware that fresh water is more compared to the land mass. Sorry, the water is more compared to the land mass, but the fresh water is not that much. So from where it comes? Everyone is aware about the hydrological cycle. But the point is that whatever the precipitation received on land is more compared to the evaporation from the land. And just opposite on the ocean, precipitation is less but evaporation is more. So question arises then how it make a balance? In global hydrological balance, when the water cycle is a closed system, thousands of cubic kilometers per year will calculate on this. Precipitation on land is 110, while precipitation on ocean is 380. While in ocean, the evaporation is 420, and inland evaporation is 70. So there is a difference of 40. This is the runoff. If we can manage it, we can harvest it little bit, then this blue planet will be blue forever. Means there will be no water scarcity. But is it happening? Just overview of what hydrological cycle is. Because this presentation is based on the water-centric things. So we should understand what is the water and technical aspect of water, not only social aspect. So input is equal to output. If we say what is the precipitation, it is the mixed bag of evaporation, percolation, evapotranspiration, soil moisture and runoff. Out of this, you can manage or you can play with the runoff. And this is the story all about this. So whenever we say ki this is a big problem and how it will be happen and whether it is possible or not, solution is there. In rural area, we can work with the watershed area concept. In urban area, we can do the rooftop rainwater harvesting. Everyone can play their role if we really want to save this. Whatever I am showing, it is the work done in Chambal River Basin, Mahi River Basin, Narmada River Basin and Tapi River Basin. I know you all are engineering students, so no need to explain what is the importance of basin and how it works. Now come to the drylands. At a global level, you can see This yellow shade belongs to the drylands, arid and semi-arid things. This red one is hyper-arid, which is almost desert and desertic conditions. You can see the quantum of arid and semi-arid, semi-arid portion in the globe. Now come to what is the why I am talking about the drylands only, because in drylands portion 18% is forest, 28% is barren land, 25% is grassland, and 14% belongs to the cropland. I am just doing the prelude of my presentation. Now come to the Indian aspect. This all purple area is semi-arid and this yellow one is arid one. This is the most challenging as well as potential area. Most of the biodiversity located in this portion, most of the population belongs to this portion. Still, we are not doing properly. Means we are not managing our natural resource properly. Drylands cover almost 40% of the earth and most of the biodiversity belongs to this. And if you ask me what is the actual definition of dryland, see several agencies, several scientific communities, they have defined drylands in different way. But in a simple way, the areas where the potential amount of water that is transferred from the land to the atmosphere is at least 1.5 times greater than the mean precipitation. इन मतलब मोटा मोटी अगर हम बात करें तो जितना पानी मेरे पास है उससे 1.5 गुना पानी की खपत मेरे पास से होने वाली, दैट इज द ड्राईलैंड. तो ये जो 1 से 1.5 गुने का अंतर है इसको कैसे कम करना है, क्या इसको हम कम कर सकते हैं या नहीं कर सकते, सारा मामला इसी पर है. एज आई एम सेइंग कि मोस्ट of the biodiversity habitat or niches they are located in this drylands only. It is the most fragile ecosystem and once desertification is done it is irreversible process, and if this niche is destroyed means that portion is destroyed will reduce the gene pool for future. And water and soil is most precious commodity for food grain, so food security will be the big questions. These are some things about this, what is the P and PET ratio. So we'll deal with the arid and semi-arid, and basically semi-arid will be my main focus. Why it happens? Major problem is deforestation. We need development works, so we need some soil or some land, and from it will come out. Forest is the main thing just to destroy. रोड चौड़ा करना है, हमने घाट काट दिया. मुझे हाईवेज बनाने हैं, मैंने पेड़ काट दिए. And see, development has to be happen. Then where is the balance? Just one thing I just want to state in the all students. जब हम एक बड़ा ट्री काटते हैं which is 100 to 150 years old and we plant a small sapling which is hardly 1 to 2 year old. Simple arithmetic. 150 minus 2, 148, or even 100 minus 2, it is 98. From where you will recollect that 98 years of nature and natural ecosystem. So whenever we want to have a development, we should have some alternative paths. Again, come to this. So you will say कि मैडम तो खूब डरा रही है. So is there any solution? Yes, there is a solution. You understand the situation, then you do the feasibility, technical, environmental, legal, and social. Then make a visionary plan. Then have a dynamic micro planning and participation of stakeholders. And most importantly, you should have a patience to do this. You should be a very passionate. And third and most important thing is persuasion. It was the prior condition. You can see the dry, the green, there is hardly green. Most of these things are brown. One small girl, she is holding wood logs for the burning and to cook the food. One lady, she's having two bedas or two water container on her head, and she walks 7 kilometers to fetch 15 liters of water. 7 kilometers means if you are at IPS, from IPS to Burpur at least, I think, or little more or less. So that much she has to walk one side. Just think, but it can be changed like this. If water is available, first crop is assured, second crop is also assured. Once you are having little more water, you can go with the cash crop. You can have some technology infusion. You can have secondary and third generation activities also. And these are the real pictures. These are not taken from any image. So it can happen, but it requires 3 Ps and at least 6 to 7 years. So how we do the SWOT analysis, and then we decided for the approach. There are three approaches. One is sustainable livelihood approach, then the watershed area development approach, and third one is ecosystem approach. But we use the mixed bag of this, and we forward this. So you can see one is brown part, another is green. How it will happen? So this is the generic roadmap from dryland to dreamland. We understand the situation. When we do the technical feasibility, then we involve the community, because community will be the owner of that program. Then we do the training and capacity building, right from farmers to our team also. Then we start with some small interventions. Then we do the convergence of different source. Then first generation activity is followed by the second generation activity. We intensify this activity, and by the end of third year, we'll get the water security, food security, and financial security. So it will reduce the migration, literacy rate will be high, and then they will invest their money in health and other things. So that will be the first step for the dreamland, but it will require 5 to 6 years, and then you get the sustainability. So we start with the involvement of community, and then we do the water conservation and soil conservation, followed with the massive plantation, and have an alternative source of energy. That's why they will not go to the forest and cut the trees. So the result of this, or the outcome of this, is the farm productivity is enhanced and the increased green cover. When it happens, then we'll create the CBOs, that is community based organization, and they will manage all the things, and the impact of this is food, water, fodder, timber, financial security, which lead to the reduced migration. There are this is the roadmap again, why, what we want to do, how I want to do, and why. Like one example is this: we want to do the planning. What will be the main component of the planning? It will be the micro planning by considering all details. So we'll get the very specific plan, which is the most important thing. You invest your energy at least for 50% to make a proper plan. Then only you can achieve the things. So these are some components. When I'm talking about the micro plan, so we need required information, ideas, knowledge, time frame, and community. So this is the roadmap, how it happens. I'll just go fast. Once we go for with the micro plan, we'll achieve some development. But development is a continual process. You can't say कि इतना हो गया मतलब development हो गया. No, it is going on. So we need a continual improvement. Where is the gap? We'll do the gap filling, introduce the new technology. It will lead to the sustainability. Again, through the continual improvement, then you will achieve the prosperity. So whatever I am talking about, the development, then sustainability, and we are on the way for the prosperity. Again, prosperity is a dynamic word. If I am having a car, I am a prosperous. But if I am having someone having the BMW, then who is more prosperous? So it is comparative as well as dynamic thing. So At a certain level, if you achieve this, then you are happy enough. Again, we'll with the visionary plan, micro plan, execution, M&E, and sustainability plan. So we work in the holistic way. Economical development, social development, and infrastructure means from Antyodaya to Sarvodaya. We work at different levels. This is the smallest is the micro level. We start with this. And micro watershed development, this is our main approach. And if we work from the reach to valley approach, we'll have this kind of picture. Water is trapped, so rivulet is regenerative. Because of this well is full of water and secondary crop is possible. And in Hindi, we usually sing a poem or recite the poem for our tribal community and other community कि दौड़ते पानी को चलाओ, चलते पानी को बिठाओ और बैठे हुए पानी को छिपाओ और फिर देखो जादू क्या होता है. And it happens. So we start being a scientist. We start with the research and extension. We do the projection of climatic factors using different models, and then we go with the vulnerability status. We compare our past for last 100 years and do the projection for coming 100 years. Means up usually up to 2099 तक का हम projection भी करते हैं from for temperature, rainfall, and the water vapor. Then we do the knowledge and capacity building. We aware the community for the climate change and other aspects. Then we prepare the community to take it. So community understand what to do and what not to do. Then revival of past. We work with the rivulets. We increase the green cover and we reintroduce the underutilized crop and agriculture practice. Then come to the resource security, water, soil, and seed. Then we go for the crop diversity, that is multiple crop system and horticulture. Now skill development is another aspect which is very required in the village. And then we collaborate with the other institutes. And the third one is the whatever you have produced, it should go with a proper market link or market chain or supply chain. So this is the thing of getting money out of this. So marketing and value chain. So number one thing is how community is involved and what they are doing. They know each and everything. थोड़ा सा पर्दा हटाने की जरूरत थी, otherwise they understand it so well. Then we do the consultation with the local. He can explain you कि where is the resource and how to do it. So this is the thing. And so you can see that one tribal person can explain you where is the potential and how to do it. So these small things has to be under consideration. So we can go with a very good plan. Otherwise, you are a foreigner for them and you don't understand the ecosystem properly. And if you say no, this is the right thing or this is the wrong thing, it won't happen. It is not the correct thing. So these local people will involve and they will tell you because they are residing over that area for a generation to generation. So they are aware कि अगर हम उनको पूछते हैं कि ये छोटा नाला कब तक भरता है, if I'll go and I'll say कि it's a dry one side, so ना यहाँ कोई potential नहीं, but they'll say properly कि ये इतने दिनों में पानी भरता है, पानी कहाँ से आता है. So these things should be considered. When we do the projection of climate change, for different climatic factors like rainfall, history and projection, you can see this is from 1951 to 2019, and this is the rainfall projection, how it will happen. And one very important finding is that see, I am working in 4 states and I did vulnerability study for more than 20 projects. So there is a very interesting thing coming out that the rainy days will be reduced, but the days of disaster will increase in coming years. And the distribution of rain, it will be more in August and September compared to last week of June and July, which was happening in back years. So that is the thing. So we have to consider this also, and accordingly then we project the things. आप लोग तो सारे इंजीनियर हो, so आप जानते होंगे कि R लैंग्वेज यूज करते हैं हम 3D डाटा एनालिसिस के लिए. So I use this, and this is the analysis of one small project just to show you. Now, this is a common trend. What I found is in history, the rainy days was 67, but the projections they are showing 79 days. Means increase in rainy days. In history, the minimum rainy days were 43, but in projection 34. Maximum days are more or less similar. But days of disaster means when there is a rainfall of 100 mm in a day. मतलब 10 सेंटीमीटर एक दिन में बारिश होने वाली हो, ऐसे दिन आने वाले समय में 70 दिन होंगे और एवरेज रेनफॉल कम हो रहा है. अब आप यू कैन आस्क मी कि प्रोजेक्शन तो आप 79 दिखा रही है, ऊपर से ये है, ये इसको कैसे कोलैबोरेट करेंगे? तो 79 डेज में भी काफी impartial distribution है या it's not even distribution. That is why it is looking like this. So this aspect is very essential to understand what will happen in future. This is just projection. ये ऐसा नहीं है कि मैंने भविष्यवाणी कर दी ऐसा ही होने वाला है. It is arithmetic projection. Because of this study, we can now understand the terrain, what is the forest cover, how much biodiversity is there, what is the dry and drought prone area, what are the degree of soil erosion, what is the water scarcity problem. Now we can understand the actual position. Now this is the time to understand and then make a proper plan. So after making a plan, we कन्वर्ट इनटू द माइक्रो प्लान. माइक्रो प्लान कैसे है कि अगर मुझे 30 दिन का काम करना है तो हर दिन की एक्टिविटी हम प्लान आउट करते हैं. अब आपको ये जो मैं डैम दिखा रही हूँ, इट इज फ्रॉम द अलीराजपुर. अलीराजपुर डिस्ट्रिक्ट हमारा एक बैकवर्ड डिस्ट्रिक्ट है, एंड ये डैम हमने लास्ट ईयर जब पहला हमारा लॉकडाउन लगा, उसके बाद में कुछ थोड़ी सी सहूलियत मिली एंड गवर्नमेंट ने हमें कहा कि वाटर कंजर्वेशन के काम तो करने ही है, तो आप इसको स्टार्ट करें. And in 58 days we have completed this. और इसमें सारे आदिवासी लोगों ने श्रमदान भी किया और लेबर तरीके से वेज भी किया. And the result is that this rivulet is full of this rivulet was full of water for 10 months. अभी बारिश आने के कुछ दिनों पहले तक इसमें पानी था. So this is the revival of past, one thing. Then when we do the conservation water means why we want to do this? To expand the rainwater harvesting, then we water storage and conservation and water use and irrigation efficacy. इसके भी example देते हैं. So we start with the leach area treatment. So you can see this, and this is because of the continuous contour trains. See the impact. मीन्स जैसे मैंने कहा कि तोड़ते हुए पानी को चलाओ. सो दिस इज द फर्स्ट स्टेप. वॉट एवर इज द वेलोसिटी, यू हैव टू चेक द वेलोसिटी, एंड दिस इज द रिजल्ट. नाउ वाटर इज कमिंग लिटिल बिट डाउनवर्ड्स, एंड these are some very small indigenous structures, and you can construct it in series. So you can see this water is deposited here and there. Now we are at the position, दौड़ता हुआ पानी चलने लग गया और चलता हुआ पानी रुक रुक के चल रहा है. Now this is the thing from the first or second order of small rivulet. You can see the pre-operational picture. Very small, you can say the cross area, and this is the result. And what is the financial support or finance required is only 2.5 lakhs, 2.5 लाख रुपया. अधिकतर प्रोफेसरों की सैलरी 3 लाख रुपया होती है. आप 2.5 लाख रुपए में इतना काम देखिए, एंड Now, at least for 20 years, they will enjoy this water. So this is the beauty. But it can be happen, or it is possible at the first or second order. मतलब जहाँ नदी बन के चली है, वहीं पर ये possible है. And again, this is a picture from Jhabua district. There are several number of such structures are there, and Milind sir has constructed around 4,000 such structures in different pockets, different habitats. So this is, you can see this attire, so you can identify that it's from very backward, or not exactly backward, from very potential area. Be positive. So this is another part when the micro planning, technical feasibility is possible, and you can see the all communities involved. This is a very recent picture. We did it in Alirajpur district, and this is from the month of June only. So many young people they come forward and they said कि अगर हम गांव का काम गांव में करेंगे तो हमें गांव में रहना पड़ेगा और मजदूरी भी मिलेगी. One experience I would like to share. I don't know it is a positive or negative, but one young person he said कि यहीं पर मैं अगर काम करूंगा तो मुझे नया मोबाइल लेते आएगा, एंड्रॉइड मोबाइल खरीदना चाहता हूँ. So I am happy for him कि यहीं पर काम करिए और यहीं पर पैसा कमाइए. So we on our part we were able to generate some wages, some maintenance, so villagers can work in the village and they can earn some money. This is one part. Second part is that if we are doing this kind of soil moisture conservation work, this water will percolate inside, and we have developed some small ponds also there, so that I'll show you further. This is me and Milind. We always be there at the planning stage, and Milind sir do all this survey, and I'll just assisting him. So you can see this is another site. If we meet again in next year, I'll show you what we have did here. So just remember this photo. So the result of this community own the things. So they know that this is done by me, it is developed by me, or it is created by me, so it's my own. And now they will take care of it also. Certain examples which are done by the community and owned by the community. So we start with the first, second order, and we go up to the fifth order, usually 4th or 5th order. These are another some structure. Milind sir will explain in length, but this is the Gavian structure. We just want to trap all the possible drops of water. Considering this water is not only belongs to this community or this part or to me only. It is the right of each and everyone. So अपने हिस्से का पानी हम अपने हिस्से से में थोड़ा सा पानी को जमा करना है और बाकी अगले के लिए बचा के रखना है. दिस इज अर्दन नाला बंड. हम अब जमीन पर आ गए हैं. ये हम इस तरह का स्ट्रक्चर बना रहे हैं. अर्दन नाला बंड की खासियत ये है कि जो चीजें वहां पर उपलब्ध है उन्हीं से उन चीजों को बनाया है. एंड वेरी साइंटिफिक स्ट्रक्चर्स, बट it is consist of all local available material. So this is another part. This can happen in some farm also कि जिसके जमीन जिसके खेतों में भी काम कर सकते हैं हम. All technical aspect will be delivered by Milind sir. So I'll just show you what we have done and what is the impact of this. And because of this kind of farm pond, the irrigation is assured. Even if the water will be percolate inside, so the water level will be rises, maybe in very small quantum, but it will. Now come to the traditional pond system in Rajasthan, which is always synonymous with the water scarcity. But in my opinion, it should be synonymous with the water management. When we are thinking of Bikaner or any desertic area, we always think कि वहाँ तो पानी है ही नहीं. लेकिन हमें अपनी सोच बदल के ये करना है कि वहाँ जितना भी पानी है, they know how to conserve it. और जिसके बाद जितनी कम चीजें होती है वो उसको उतना सहेज के रखता है, उतने जतन करके रखता है. एक समय था जब मालवा में कहा जाता था कि डग डग पे पानी है और उसके अगले पल पे तरह तरह का खाना है. You must be know कि now we are going toward desertification. कुछ ही समय में मतलब फिर कुछ भी टिकट्स लग सकते हैं. मालवा भी उस ओर चल पड़ा है कि जहां हमने अपनी वन संपदा को खत्म कर दिया है और उसके जगह हम प्लास्टिक के पेड़ों पे ज्यादा बिलीव करते हैं. You may feel that I am little bit harsh in this aspect, but one tree means at least 25 types of insects and birds. If you cut one tree, means you are destroying that much of fauna. And अगर अब आपके लिए सोचिए कि आपको वहां से उठा के किसी और जगह रख दिया तो आपको एडजस्ट होने में कितना समय लगता है. When you are having a full grown brain with you, full grown muscles with you, and pocket full of money, but what will the all these faunal elements will do? So again, coming to the point, this is the revival of some traditional ponds which are located in the village. We have a culture of water conservation in our community. No doubt or no question in which part you belong to. This is from the Rajasthan, Bharatpur. My team is there and they are doing wonderful work. So this was traditional pond which were encroached by the community and was used for all nonsense things. But still we want to revive it and we help them to revive it, and you can see the difference. And in dry lands, when you see the water, nothing is like that. इसको देखते ही ऐसा लगता है कि सब कुछ मिल गया. Now we'll go to the ravines. These are the ravines. When we talking ravines, बोलते से या बिहड़ बोलते से हमको चंबल के बिहड़ बोलते से हमको डाकू और इस तरह के सारी चीजें याद आने लगती हैं. But ravines itself a very good ecosystem. It is the homeland of so many plants and animals. And ravines, it is just one habit of any river who cause these kind of structures. The most important aspect is that soil is very loose. So how to conserve water in such areas? This is the one program which we are doing for the ravine stabilization. And one great social scientist, he said that ravines is the end of society. But I said this is the beginning of the society, and we proved it. This is the location from the Dholpur district of Rajasthan, and this is the lower Yamuna catchment, just parallel to the river Chambal, and you can see these ravines. Bihar जिसको हम कहते हैं. And this is the pre-operational, and you can see the quantum of water reserved there or conserved there. This picture is 10 January and this is the result in the August. At least 7.4 kilometer long reservoir is developed. And once water is available, again I'll say it again and again, once water is available, then you can draw anything on this brown canvas to make it green and then pink. Now, when we did it, we thought these banks should be stabilized with their local flora. And I am a field botanist also, so I just find out what was the past flora, and accordingly that we started re-establishment of this ecosystem. We start with some grass and some legume plants, and now it is really getting green. First it was brown, then the blue, and now it is getting green. And one very interesting story I would like to share is what is the thinking of community and how it changed. When we went here for this survey and things, तो local community they were thought कि ये भी कोई बड़े सेठ टाइप के लोग हैं एंड इनके पास खूब सारा पैसा है तो इनको बिठा के रखते हैं एंड दे कैन आस्क समथिंग कि इतने रुपए जमा करो तो हम आपको यहाँ से जाने देंगे. We said कि we are just social worker and we want to this for you and we don't have that much money and we are not a safe type of person. But after a long negotiation, they just said कि okay आप जाइए. And that fellow was continuously having a watch on it कि what is happening. And we kept all the things in the open only and all villagers they were taken care of all this कि कितना सीमेंट आया and सीमेंट में कितना आया 3,000 bags 4,000 bags इस तरह से आता. And when the project was completed and it was handing over to the community and he suddenly come to that pandal in this program and he said, I want to say something. We were little bit shocked. I don't know what he will say and what will happen. But he said कि मेरी तरफ से 10,000 रुपया आपने इतना बड़ा काम किया इसमें और जिस तरह से हमारे शरीर में धमनियों में खून बहता है उसी तरह से ये पानी बहेगा. It was overwhelming for us. Nothing like that. So that is the ownership of community. It comes because we show them what is the transparency. Every villager is aware how much cement is used, कहाँ से आया, कितने में आया, और कितना नीचे लगा, कितना ऊपर लगा. Whenever the so many foreigners come there to visit and see कि क्या हुआ है, हमने जो पैसा लगाया किसमें लगाया. So I don't need to say anything. Everything is explained by the villagers. Even इसके ऊपर ही एक और डैम बना है. It is by the government and one minister he was on the visit. गांव वालों ने उनको कहा कि वो मत देखो आप आपको एक चमकीला डैम दिखाते हैं. And then the minister came to see and he said कि who constructed this. At that time we were in Bharatpur. And in the night, in the 10:30, one person come and he said कि कोई आपसे मिलना चाहता है. And then we see कि this minister is on the door and he said कि कितना कम कीमत में आपने कैसे बना दिया है. और गांव वाले उसको कितना ओन करते हैं. उनको लगता है ये उनकी प्रॉपर्टी, ये उन्हीं की प्रॉपर्टी. बट यू मेक देम ओनर कि ये क्यों है. अदरवाइज इसमें आपने अगर कोई लोहे की चीज लगाई है कोई भी निकाल के ले जाए. लेकिन ownership is must. Take for example, again from Bharat, you can see this structure and now you see the difference. Again the huge water body is there, but this is a percolation kind of structure, so water will be run away and it will be in their wells. And because of this structure, more than 500 wells which are known to us, they are having sufficient water. And these upper pictures you can see, this is the time when we want to do the Bhumi Pujan or earth breaking ceremony, and they call us, the villagers, and all party person will be there and they said कि आप आइए और ये हमारी तरह से program. So again this is a kind of ownership, how they own it. But there are certain experience which are heartbreaking also. Sometimes it is overwhelming also. But if you are having a passion for this and you are having patience, then you can pursue it. This is one structure. If water is available and you are not using it judicially, it's a crime. It's really a crime in aspect of climate change. हमारे पास अगर कोई चीज है और उसका उपयोग नहीं कर रहे आप तो किस काम का. So we install one lift irrigation scheme and because of this water you can see the impact. The villager said कि जहां तक नजर जाएगी वहां तक हमने गेहूं लगाया है. इसके पहले कभी गेहूं नहीं हुआ हमारे खेतों. So मतलब हम तो कहते हैं कि हमें तो कई बार नोबेल प्राइज मिल गया है. एक बार नहीं कई बार मिल गया है. किसी के चेहरे की खुशी ही सबसे बड़ा प्राइज है. सो यू कैन सी द रियली जहां तक नजर जा रही वहां तक गेहूं ही गेहूं. और यही वो लोग हैं जिनको हम कहते हैं कि दे वेर इन सम एंटी सोशल एक्टिविटीज, नाउ दे आर रियली गुड फार्मर. तो एक ये भी एस्पेक्ट है. वन मोर एग्जांपल, यू कैन सी दिस पिक्चर फ्रॉम दिसंबर 2019 जब कोविड की कोई आहट नहीं थी. जनवरी आते आते थोड़ी सी सुगबुगाहट होने लगी थी कि इस तरह से कोई बीमारी आने वाली है, कई जगह पर हो रहा है. एंड वी आर वेरी कॉन्फिडेंट कि हमें कुछ नहीं होता है, हम तो बहुत स्ट्रांग लोग हैं, हमें इंडिया में इस तरह का कुछ नहीं होता है. लेकिन हो गया. फिर भी काम बंद होगा और उसके बाद में फिर काम शुरू किया मार्च में और 30 जून को ये काम कंप्लीट होगा. इसकी क्या पिक्युलरिटी है, क्या स्पेशलिटी है, मिलिंद सर आपसे डिस्कस करेंगे ही ऑल टेक्निकल एस्पेक्ट्स. लेकिन इस तरह का सेमी लूनर स्ट्रक्चर है जो अपने आप में कई सारे सेमी लूनर स्ट्रक्चर के साथ में बना है. वेरी इकोनॉमिकल बट वेरी स्ट्रॉन्ग स्ट्रक्चर. One more structure from Alirajpur only. You can see the difference. And when it was filled just in 15 days back, ये जो फोटोग्राफ है नीचे का बिल्कुल पहला ही फिलिंग हुआ इसमें. गांव वालों ने इसका शूटिंग किया और उसमें सारे बच्चे बड़े स्मार्ट होते हैं, हमारे गांव के बच्चे भी बड़े स्मार्ट हैं. उन्होंने उसमें कोई एक बड़ा सा म्यूजिक कोई गाना वाना डाल के वो सारे पूरे ग्रुप में सारे दूर सब दूर फैलाया और कहते हैं कि हमारे गांव में गंगा आ गई. दिस इज वन मोर वेरी केची स्टेटमेंट फॉर मी कि हमारे गांव में अब गंगा आ गई. तो दिस इज अनदर एग्जांपल. व्हाट आई वाज डिस्कसिंग कि पहले ब्राउन था देन ग्रीन एंड नाउ ब्राउन टू ब्लू एंड ग्रीन. सॉरी ये गलत लिखा गया बट यू कैन सी दिस ग्रीन पैचेस. अगले 2 साल में ये काफी और इम्प्रूव हो जाएगा. ये देखिए आप कितना लंबा वाटर बॉडी इसमें दिखता है. Now that was the output. Now come to the impact. Because of this, you can see the well full of water. जिस तरह से हम अपने घरों में वाटर टैंक से या हाउस से पानी निकालते हैं इतना पानी भरा हुआ है इस कुएं में. Now water is available. You have assured irrigation. Now this is the time to reintroduce whatever you are having in past, means underutilized crop. आजकल तो बहुत फैशन में है कि कोदो खुद की खाओ, राजगिरा खाओ. ये तो सब हमारे कल्चर में था. अब आप देखिए कि इस तरह से अगर फिर से चीजें एकत्रित की जाए तो क्या हो सकता है. दिस वाज द अर्लियर क्रॉप पैटर्न इन ट्राइबल लैंड एज वेल एज इन एवरीवेयर, इवन इन मालवा आल्सो. हमारा अपना सॉर्गम था, हमारे अपना बाजरा था, हम तिल भी लगाते थे, हम अरंडी भी लगाते थे, कई तरह की फ्रेंच बीन्स या इस तरह की बीन्स भी होती थी. हमारा अपना सामा था, राजगिरा था. लेकिन वी हैव फॉरगॉटन नाउ इन मोस्ट ऑफ द फील्ड्स यू विल फाइंड द सोयाबीन. अगर आप बच्चे लोग जो पता नहीं सिर्फ स्टूडेंट है आपके फैकल्टी है भी, लेकिन अगर जो फैकल्टी है वो शायद थोड़े से सीनियर होंगे, उनको याद होगा कि अगर खेतों में हम देखते हैं तो सभी दूर सिर्फ सोयाबीन सोयाबीन. सो वी आर लूजिंग द डाइवर्सिटी. एंड एक बड़ा किसान सिर्फ सोयाबीन अफोर्ड कर सकता है लेकिन एक मार्जिनल फार्मर नहीं, क्योंकि उसके लिए फूड सिक्योरिटी भी चाहिए. अब हमने खेतों की तरफ आए तो जो भी हमारा सॉइल है वी नीड सम बायोलॉजिकल एक्टिविटी इन दैट. मीन्स वॉट एवर द ऑर्गेनिक कार्बन इज देयर वी हैव टू इनहांस दैट एंड वॉट एवर द केमिकल्स वी हैव टू रिमूव दैट. मीन्स स्लोली स्लोली. मैं ऐसा नहीं कहती कि एक ही दिन में आप सब ऑर्गेनिक कर दो. इन आवर कल्चर इट वाज लाइक दैट कि एनी प्लांट एनी क्रॉप the upper 20% is for human, middle 60% is for cattle, and remaining 20% is for soil. But we have forget this. Now whatever we want all 80% for us. No for cattle, not for cattle and not for soil. If it will remain in the soil, the whole ecosystem will be functional. And it will full of humic acid, it will full of humus, and Because of this, the cation exchange capacity will be increased. It will regulate the soil pH and it will maintain the soil moisture. Okay.
तिथे कुठे click करू?
Sorry. And it will stabilize the excess carbon in soil also. So carbon in one part, it is a friend as well as it is an enemy. Now you have to decide which form of carbon you want. You want a sink or source, or you want a depository. It is up to you. Now there are different means to make the organic carbon rich manure. It may be any native composting or biodynamic compost or simple vermicompost or micromedia compost. So these are the very small interventions but very valuable interventions. It will help to the soil to maintain its fauna and microbial fauna. अब हमारे खेतों से केचुए भी गायब हो गए, इनको फिर से लाना है. As I am saying, if water is available and you are doing nothing, it's a crime. Likewise, if you are keeping your soil or your field naked, again it's a crime. It should be blanketed properly. You may blanket it with some artificial means or with some natural means. So if you do this, then carbon will be your friend. If you kept it naked, then it will be enemy. So this is the one major aspect of climate change and adaptation strategies also. Now we have maintained our organic carbon. Now we have heat in our field. All the food security is maintained. Now we can go with some additional thing like vegetable uh, and some crash crop. So you can have some additional income in your pocket. There are so many people who said कि एक ही तरह का क्रॉप ना लगाओ, लेकिन हमने वो भी एक्सपेरिमेंट किया. The one village is growing tomato, one village is growing pumpkin. So market can come to that village and farmers can get good price, or whatever they have invested they will get more out of it. So this is one example. But when we do this with the soil, then you can have a very good crop and the yield will be increased and the taste or the nutrient component in the crop or specifically in vegetable will be high. आपने अपने घर में सुना होगा कि अब तो खाने में कोई स्वाद ही नहीं है. In our childhood also, the tomato was a fruit. We can eat it like a fruit. Now tomato is very thick covering and pulp is less. So you want to have a nutritional value also. You have to work for the soil. Now we have all the resource security. We are having good water. We are having good soil. Now it's time of seed. You should have a good seed, improved seed, drought tolerant seed, and have a patience how to cultivate it and when to cultivate it. There are certain you can say underutilized things or some indigenous thing. These are the seeds from the tribal pocket only. From Satpura height in Maharashtra, it is तोरणमाल नाम का एक हिल स्टेशन है छोटा सा, वहां से ये पिजन भी कलेक्ट किया हुआ है. एंड इट इज पेरिनियल क्रॉप, मतलब जैसे हम तूर या ये जो एक बार लगाए और 6 महीने में उसका क्रॉप आ गया और निकाल दिया, बट दिस इज पेरिनियल, मतलब ये कई सालों तक चलने वाली चीज है एंड इट इज ड्रॉट टॉलरेंट ऑल्सो। सो ये जब भी आप लगाएंगे, अगर वाटर स्कैरसिटी भी है तो भी ये सर्वाइव करेगा। एंड एवरी इकोसिस्टम हैज इट्स ओन जीन पूल, वी हैव फॉरगेट ऑल दिस थिंग्स। हमें तो कोई भी चीज चाहिए, मुझे तो आज यहाँ पे कीवी भी लगाना है, कीवी का सीड तो मैं ले आया, लेकिन कीवी के सीड को या उस प्लांट को लगने वाला एटमॉस्फेयर में कहाँ से, तो उसके लिए मुझे चाहिए कि या तो मैं प्रिसीजन फार्मिंग में जाऊं, विच इज नॉट पॉसिबल फॉर ऑल द पुअर फार्मर्स। लेकिन अगर आप प्रिसीजन फार्मिंग में भी जाते हैं, so and you follow certain norms, you can get very good results. This is from the precision farming. This is some papers, yellow and red. This is cantaloupe और हम जिसको खरबूजा कहते हैं, इस तरह से ये भी चीजें ग्रो की जा सकती है। But the most important thing is management. You have to manage the soil, the water and time. समय सूचकता जिसके पास नहीं है वो इस तरह का काम नहीं कर सकता। सो दिस इज मोस्ट इम्पोर्टेंट थिंग। एंड इन माय लास्ट 30 years experience, I also grown up with this. When I started my career, I was very young and I was hardly understand anything. But this community taught me how to see, how to observe the things and how to integrate the things. But above all, time. You should know how to start within the time and how to finish within the time. Then only you can get the success. And this is a very generic mantra which can apply anywhere. See, when we grow this, again it was lockdown period. And all my micro planning was failed there because we were just unable to market it. But it happens once in a while, once in 100 years. So don't worry much about this. Again, if you can do it properly, you can manage it properly, any small farmer can earn at least 3 to 4 more times whatever he is earning from its conventional things. But I have always a very big debate with other scientists also. Okay, I always said that food security is first. We can't offer them all the fancy items. There is market is so dynamic. One day this mircha is 40 rupees kilo, another day it was 100 rupees kilo. So we can't play with their food security. So food security is first, and then only you can go with all these things. Now, small technology in future can give you more productivity. These photographs is from Narmada Bank in Kukshi, Dhar district, and because of these very small interventions, the productivity has increased 2.5 times. जिसको 1 रुपया मिलता था 2.5 रुपया मिल गया। एंड जितना ज्यादा प्रोडक्शन होगा और अगर ये कलेक्टिव मार्केटिंग की तरफ जाएंगे तो मार्केट विल बी एट देयर डोरस्टेप। सुबह सुबह 4 बजे बड़ा सा ट्रक आके खड़ा हो जाता है और सारे लोग अपना माल उसमें लोड कर रहे हैं। नो नीड टू गो टू इंदौर और some other places because market is coming to their doorstep. This is one major aspect. This is one more thing. And if you are able to do the all integration of activities at one place with some medium farmers, that will be a very good showcase and that is a really good example. Some more technologies like hydroponic. We are having in Jalgaon, we are having a BBO course for the greenhouse technology and agriculture. And me and Milind sir are the director of this unit. And we always offer some very small but very useful technology for them. So you can see this strawberry is being uh, not exactly cultivating, but it is in the hydroponic system. And in Jalgaon district, which is really having more temperature compared to Indore. This is parsley and these are tomatoes, they are growing with the hydroponic. Very small or very less quantum of water is required to run this system. Very in protective area you can do in your house also, and you can get very pure material. We are not putting any chemicals in it, we are putting some elements. Try to understand, we are not putting any chemical compound, we are putting some elements on it. Even whatever I have shown in this picture, it is half acre poly house, and we are putting inputs like any nutrient. It is in ppm, 1 milligram in 1 liter. इतना कम देना पड़ता है इसको. So we are, it was eye opener for us also, कि हम कितना ज्यादा वेस्ट कर रहे हैं. So यहाँ पर भी इसी तरह से किया जा सकता है, and we can grow anything, believe me, and we did it, and anyone can do it, and we are having so many sessions for our farmers, and they are doing this very nicely. Now, a very important aspect is to raise or to increase the green cover. To increase the green cover is one statement, and to increase the green cover with the indigenous species is another one. Second one is difficult but most needed things. If you can reintroduce whatever you have in the past, then it will helpful to establish the ecosystem in a very small time. मैं जो कह रही हूँ शायद सिविल इंजीनियरिंग के बच्चों को इतना डाइजेस्ट नहीं हो पा रहा होगा कि क्या कह रही है मोहतरमा, लेकिन आपने कभी यूकेलिप्टस का पेड़ देखा होगा तो कई सालों तक उस पेड़ पर कोई भी पक्षी अपना घर नहीं बना रहा था. अब जाके कुछ जगहों पर उस पेड़ पर आपको कौवे का घर दिखेगा और किसी का. तो उसने उस पेड़ को उस इकोसिस्टम ने अडॉप्ट करने के लिए इतना समय लिया. लेकिन यही पेड़ अगर बरगद का होता या पीपल का होता या आपके आम का भी होता तो इसके ऊपर बहुत जल्दी जल्दी कई तरह के पक्षी आपको दिखते. ये बहुत छोटी सी चीज है समझने के लिए, देखने के लिए, लेकिन उस इकोसिस्टम को एस्टेब्लिश करने के लिए बहुत जरूरी चीज है. तो हम उन सारी चीजों को फिर से इकट्ठा करने की कोशिश कर रहे हैं. और कम्युनिटी को आप देख रहे हैं, इसको पहचान रहे होंगे आप, ये पीपल का पेड़ है, कुछ टीक है, कुछ आंवला है, और ये इसको री एस्टेब्लिश करना है और वो उसमें पौधे लग रहे हैं. यही सेम एग्जांपल हमारे रवाइन्स में है. यू कैन सी द स्मॉल किड्स, whatever we have planted earlier, now they are taking care of it with the help of some small bottles, some small interventions, and now they are the friends of these kids. So they are taking, it's mine, and I'll take care of this. They'll just decorating their plants. So this is how they own it, how they will feel it's my friend, so I have to take care of it. And our organization is also doing some Prakriti Shala, which is one program for the kid or school children, how to make them aware about their ecosystem. So this is one part of it. I have one more interesting story in Baswara district also, when I was in Dahod, and we were in this plantation program, and sometimes we are so, myself become so rude and I don't want to entertain anyone, but some small kids there come and they said कि we also want some plants, आप हमको भी दे दो, हम भी कुछ पौधा लगाएंगे. I said no, you will waste it. And still they were asking me, and then I asked one school teacher कि ये कुछ पौधे आप लगा लेना, and I ignored school children. And after 2 years, when I was back to the same school, I find so many plants. They were at the periphery of this school, the boundary side. And school teacher said, "Ki whatever you have left there, all these students, they have take one out of it, and they said ki they name the plants as per their name. Ki agar mera naam Bablu hai, to my plant name is Bablu, and they have planted or they have take care of more than 200 plants. So after that, I learned कि we should take this potential with us, these small kids. So this is the result you can see. So we are also learning every day with our experience. Okay? Sometimes we don't understand how to do it, but someone will show you the path. It no matter it may be a small kid or it may be a very old age person. So when we do the land treatment, we'll increase the soil moisture, it will reduce the soil erosion, and it will increase the biomass and grain, so it will lead to the more productivity. Likewise, you do the ridge area treatment, it will again increase the soil moisture, it will reduce the soil erosion, and it will increase the green cover, and it will reduce pressure on forest. It's a small or very small as well as very slow process, and slow going. You have to be very patient about this. When you do the drainage line treatment, it will again increase the soil moisture, it will increase the availability of water, and it will lead to the more productivity of the ecosystem. I am not talking about only the agriculture field. I am talking about the whole ecosystem. Again, some scientific things. If you are not doing any conservation measures, then the field will be green for July, August, September, and October. When you do the some soil moisture conservation act with some drainage treatment, this green cover will extend up to the Jan. But if you use all your water sources properly, judiciously, then it will go up to this. So this is the climax of anything. Usually it go up to this, but not in all the cases. So I have not make it all the grids. So food security is there, order is there, availability of seed at appropriate time and rate, migration is checked, and you have additional income, additional money in your pocket. So now we reach to the sustainability. So this is the integration of diversified activities on a small piece of land, which is the key of sustainability for marginal and small farmers. In cereals, oilseed, pulses, you grow all the things for yourself itself, then go for the market. I am talking for the marginal farmers, having less than 1 hectare land in his possession. So it will lead to the food security. If it go properly, if you are having the assured irrigation, then you can go with the fruit orchard, you can purchase some cattle, make them proper uh, way of intervention, then you will have more nutritional security. And then you have to learn low input and high development program and integration of all these things with the skill. That will be the sustainability. So हम ड्राई लैंड से शुरू करके सस्टेनेबिलिटी तक आएंगे. Nowadays everyone is asking कि you should do the climate resilient agriculture. We were doing the climate resilient agriculture, but some scientists like us who manipulate all the cultural aspect or practices, and now again asking to go back to your roots. So climate resilient agriculture to the climate resilient livelihood. We are having a very good surroundings and very good neighborhood and having enough resources, so we don't understand what is this climate resilient or climate change aspect. But a marginal farmer, he is facing it very acutely, very severe. If there is no agriculture work, no food, no grains, then he has to migrate. But where to go? This pandemic period has taught us so many things. Now we should take it as a learning phase for us. Everything was gone or vanished, almost vanished. Only agriculture was sustainable. But still we are ignoring. I have n number of miserable stories of this, how they have come back to their villages, Again, go to the point, climate resilient agriculture. Then we need climate resilient livelihood also, not only agriculture. If you are dependent on the agriculture, there are n number of factors which influence the agriculture and its productivity. So we need some additional livelihood also. Once you have all these things, then only you can go this कि yes, now this village is climate resilient. If बहुत बारिश आ गया तो भी फर्क नहीं पड़ेगा, 3 साल तक सूखा आ गया तो भी हमें इतना फर्क नहीं पड़ेगा कि हमें खाने के लिए भी कुछ मिले. We all are blessed. We are having enough food with us, enough power of purchase. But you ask one person who don't have anything in his pocket or in his granary. So that community is most affecting people. But there are silver linings in the sky. This is one villager from the Alirajpur district. He is BSc and now he just want to learn all this thing and he said कि मुझे कुछ ऐसी चीज सिखा दो कि मुझे ये काम आ जाए. He is demanding some skill. This is the right time to impart the skill, whatever he required. No need to ask them to learn computer or तुम्हें ये आना चाहिए वो आना चाहिए. Nothing doing. Whatever he is required, what is required in the village, we should impart that skill. And so at the old age he can have a smiling face. But for this we need so many hands, so many ideas, so many people, so many institutions. So this is the collaboration of other institutions, like from KVK to universities to the IMD, Indian Meteorological Department also. We always want to have very modern technologies which are beneficial for the community or for that ecosystem. We always welcome such innovations, technology or any good ideas. We always welcome. So these are the very small interventions. With the help of KVK, they are offering drought resistant seeds for them, and this is the part. On another part, we are the partner with the Center for Climate Change Research Institute of Tropical Meteorology, Pune, for this projection of the climatic factors, and we are working for different models, like from 4.5 to the 8.5. So these are the very advanced thing. We are also dealing with this. Now we have produced so many things. We are having many things, but how to market it and how to be a part of the value chain, that is most important thing. Again, this picture you can see full of mango from Alirajpur district. This is Safed Musli, you can see, which is having a very good potential for the market. But can you believe this mango is sold in this mandi at the rate of 10 rupees per kg, and you are getting at least 50 rupees of a kg. So this difference, we need to have a collaboration of this farmer, and that is our next step. We do it. We are doing it, so they can have a proper thing. And after that, we'll go for the value addition. But we are here only up to this. Now, not yet with the value addition thing. But there are so many potential crops like this muesli and this custard apple, mango is there, and so many very unusual vegetables are grown there. So we can work with them, and we are trying to grab the things. So all these collectively can come forward and have their own system. Now we are having fruit also in your field. It's the time to have flowers. We offer some people for this floriculture, and it's very beautiful and really very fragrant kind of farming. कोई भी फूल को देखकर हम खुश होते हैं, उससे मिलने वाले पैसे से हम बहुत ज्यादा खुश होते हैं, हम हमारे पास so a very small piece of it they can earn very good. just 0.1 hectare they can earn 300 to 400 rupees per day. I'm again saying कि जो भी मेरे स्टूडेंट्स हैं साथ में डोंट थिंक 400 रुपये में क्या होता है 500 रुपये का तो हम एक वही खा लेते हैं पिज्जा पिज्जा बर्गर व्हाटएवर इट इज बट अबाउट दिस हमारा 400 रुपीज ये उनके लिए बहुत खुशी की बात। अब समय आता है कि हमें हमारा सीट पक्का चाहिए सो वी आल्सो ट्राइड फॉर द सीट मल्टीप्लिकेशन and now they are giving their own seed, quality seed at very low cost and easily available. So this is very big step. कि आपका खुद का seed it is certified seed. It is not anything. It is certified by the certified agency of the government of India. So this is another step. Now you have water with you, now you have good soil with you, and you have seeds with you, your own seeds. Now, अभी भी कुछ कहानी इस इतने से ही कुछ नहीं होगा. Now you need some 1 to 3 small things like food this maybe chick or some goat or buffalo and cow and इतना हो गया अभी भी कुछ बात. Now we need some skill and our woman power. I can do it. We can this artifacts from marble from Rajasthan. This is Tulsi Mala from Rajasthan. This is something with the grass from Rajasthan. We have something called our young villagers also. We train them and they so like this person is trained in some very small interventions like अंदर पकाओ और जो भी छोटा मोटा काम है कभी का उसके लिए. And he is happy because he will in the village only. This fellow is in the marble architects and working in some small village from Rajasthan, and he is having own website which we help him develop, and now having an online business. So it's very good for me. This is the thing or some studies on the technology transfer when we are working with the IIT Delhi, and this is the you can say furnace and for this angle making. It was very old kind of thing. So IIT Delhi they come forward and they ask us ki what again we all these are beneficial and there is a sitting problem and because of the temperature there are certain problems so they sort out the issues and now it is functional. This another photographs again with this help the IIT Delhi and Rutec, you must aware of this. And it is the machine for the Tulsi Mala making, and we improved little one. And because of this, now these women can do it more work in small time. This is from Rajasthan unit. These are the tires with our ministries they are doing, our women they are doing. We also offer some computers and financial literacy training also. This is a very good system. All this they are involved in it. Another we are using local grass. And this is the grass and you can see the product. This is the woman empowerment actually. These are the woman in the now they know what is the importance and of getting money on that by doing something. So they can have some money on their own. And I always said yes, for them money is the power. Even 25 rupees means a lot for them. They are getting it, but before that, we always make sure they should be trained, not very high scale trained, but at least something, maybe a short term training sort of. So you can see what are they are doing. They are doing protein, they are doing some silver work. This is chain making and so many other things. So she is saying, thanks for giving me the confidence. This is a very old story. She is an old lady from our district, and at that time I was having some students from the Boston University for as interns, and they said we want to do something for rural upliftment livelihood. So I asked, yes, we'll go to the village and just discuss with the farmers. It is 15 years old story I am saying what I am discussing. You can see this mobile, so you can understand how old the story is. And during the meeting, just her mobile was ringing up and she said कि मार लाख से मतलब अभी तो समय लगेगा मैं मीटिंग में हूँ. So this is the confidence. I love it. Simply I love it. So she's saying thanks for giving me the confidence. She is confidence because she know what to do and what not to do and how to earn some water. Come back to again some academic things. We restore the ecosystem. It is a ecological impact. So there is handsome money in the short duration. It's the economical aspect. We work on the removal of CO2. What I was saying, the CO2 is a friend and CO2 is the enemy, and less use of chemicals. So it's the environmental aspect. So at the end of it, we can have a low carbon and high development things. This is the time to have a protective ecosystem to the productive ecosystem to the regenerative. सिर्फ प्रोटेक्ट नहीं करना है, सिर्फ प्रोडक्ट नहीं करना है, उसको रीजनरेटिव बनाना है. एंड वी डिड इट इन more than 300 villages, which is you can say it's a climate resilient village, and there are the showcase or the prototype of our work. This is something really some theoretical things, so I don't think my students will be interested for this. And this is the one you can say formula. And the red one is the interventions, blue one will be the outcome, and green one is the impact. So we do the conservation of surface water and the conservation of water, and because of it, soil moisture is conserved, and we conserve the topsoil also. Along with this, training and capacity building is the main aspect. So because of this, water moisture is available, community is ready to manage the things, maybe in the form of federation or CPOs, and soil erosion is reduced little bit. So collectively, land productivity is increased, and the impact is that water source become perennial, and most important thing is the local hydrological cycle is functional. Because of that, food security is there, and more carbon sequestration is happening. Now you can go another second generation activities, that is social forestry, introduction of horticulture activities, and you can have floriculture, fruit orchard, and vegetable cultivation. So you will have a nutritional security, financial security, and livelihood security. And because of the animals and this biomass increase, fodder security is there, so more milk production. And because of this cow dung, you can have a biogas and vermicompost. So this is the one cycle, very integrated cycle, which is very proven experience or experiment we did with not less than 1 million households. And everyone is aware that we are having our goals, SDGs. So whenever you want to any goal, it is every goal is related to another. If you go with the no poverty, so you should have zero hunger, then the good health. Once in drylands, once this water is available, this green cover is made proper, having proper elements, then there is no poverty, no hunger, and road health will be maintained, and other things also. Carbon will be checked or it will be your friend, like this. So once this is happen, again I am telling you, water is the main thing in drylands. I am not talking about all humid or subhumid areas, but in drylands, water is the main thing. So I believe, or we are practicing water-centric rural development, achieving all these goals. I am not targeting one goal only. Even I don't target any goal. We work for the water-centric development, and one by one, all goal is achieved. But what is required? Three P's: patience, patience, and persuasion, and transparency and the honesty. Honesty not only for yourself, not for the community, but honesty for the natural resources. That is the most important. The small kids, they are also the part of ecosystem. And they always ask whenever I am in the field, they are from the Leadership again, and they said कि स्कूल कब खुलेगा? क्या अब स्कूल खुलेगा ही नहीं कभी? I said कि no खुलेगा. थोड़ा सा समय जाने दो स्कूल खुलेगा. और किसी कि मुझे तो बहुत पढ़ना है, मुझे ये काम नहीं करना है, मुझे बहुत पढ़ना है. I said कि yes, तुम्हें भी पढ़ाएंगे, खूब पढ़ेंगे, लेकिन हमने ये नहीं बोलना है कि हम कहाँ पढ़े और हमें क्या करना है. These are some credentials for us. My team has received some appreciation from us. We are having here and there कुछ काम करते हैं तो कुछ लोग पहचाने भी लग जाते हैं. And again, this is one photograph from the Vines, Rajasthan, and you can see the huge water body, the sigmoid shape water body. It's red. You can, if you can see it properly, one person is standing here. So you can see the huge water body and extension of the vines, and more positively, the extension of green covers. And because of these green covers, many butterflies, many birds, even hyenas, and even one crocodile is seen here. So that is the maximum or the climax of ecosystem we have tried to achieve. So save nature and nurture the future. This is my saying. And a big thanks from my community and from my team and from me and Milind and our organization. Thanks for listening us properly. And whatever question or whatever queries you are having, you are most welcome. Thank you. This is the part of one DST project also for the awareness. So that is from my side.
Thank you so much, ma'am. So, any of the
Thank you.
participants would like to have any questions or interact with ma'am?
Okay. Yeah.
That was a wonderful presentation, ma'am. Ma'am, I hope you can hear me.
Yeah, please.
Yes, ma'am. Actually, the screen got stuck and I was wondering if whether I'm communicable or not.
Yeah. Just for a while it was just playing, but now it is okay.
Okay, ma'am.
Thank you very much for
Thank you
listening
so
to
much,
me,
ma'am.
and
Thank you so much. It
I
was very
hope.
enlightening, very wonderful. And the work you have done is truly recommendable. Thank you so much, ma'am, for devoting your time to us.
Okay. And thanks for serving.
We are very honored and we are very inspired by the work you are doing, ma'am.
Thank you so very much. I am here only. If anyone has any question, anything to ask me, it is most welcome.
Sure. So if the participants have any question or any doubt, they can ask in the later session also. So the screen is hanging a bit.
Yeah.
Sir, if possible, can you please unshare and then share it again?
Yeah. I just तुझे करू ना. त्याला मोठं कर. नाही. It's over to Milind.
टेस्ट करना है ब्रिक
Sorry,
से.
ma'am, I didn't hear it properly. The voice is also breaking a bit.
Okay. Just a minute.
And this, from my side, ma'am, the screen has got stuck. It is not moving.
Yeah. So what to do?
Ma'am, I request you to please restart your system. We will wait by that time.
I'll restart my system. You restart your system.
Ma'am, we both shall restart then. We will come back in
Okay.
5 minutes. So the
Yeah, sure.
participants, we will be back in 5 minutes because there is some technical problem and we are unable to see the screen moving. So we will be back in 2 minutes. While we restart, you can rejoin.
What is the difference between stones
Thank
and
you.
brick?
Yes, sir, I can see you now.
Yes, I am trying.
Yes, ma'am, your screen is also visible, ma'am.
Great. Thank God. Okay. Please over to Milind. Yeah.
Good afternoon, sir.
Good
I welcome
afternoon.
you.
Yeah.
And
Yeah. Thank you very much and for inviting me to deliver a lecture of what I have done in far past 30 years in Central India or even in Africa and all so many different states also. So this is my experience for last 30 years and as said by Dr. Swati, shared with you that all rural development is from our side is initiated with the water conservation activity because we are all know that we are residing in a dry lands, so the water is a very precious commodity, and if there is a water then so many things can be happen very easily. So as an engineer, my first slide is the water balance equation. P is precipitation, is always equals to evaporation, runoff, groundwater, evapotranspiration, and soil moisture. These are the major components of equation. We know that the primary source of for our area the moisture is coming through the clouds, that means rains. That is the one and only source. Whatever we are seeing on the land, in the rivers, in the ponds, in the wells, or whatever, wherever the water is present, it is because of the rainfall. And we are unimodal type arrangement. There are two systems. One is bimodal and another is unimodal. That means we are receiving rains in only very few days or even अगर मालवी में बात करूं तो चौमासा, that means 4 months of the rainy season, but hardly you can say 45-50 days only, and 45 days, and if you count in the hours, only 100 hours is at maximum. So there is very few or very small opportunity that we are receiving rain. Just 3 days back, we are coming from Agra and Bharatpur through road via Gwalior and Guna and all that area. And just next day we hear from news that there is a torrential rain in just 12 to 16 hours, 800 millimeter, means almost the whole year rainfall is received in hardly 12 to 15 hours. That means it is very destructive because there is no space or opportunity for a geography to handle that much of rainfall. So you just see in the screen there are 400 square kilometer cubic kilometer of rainfall we are receiving on our Indian subcontinent, and out of which 700 cubic kilometer rains is evaporating or water is evaporating, that is 17.5%. Runoff is 1150 cubic kilometer, which is very good one, and groundwater is 21.50. That means almost 53% is we are having in the grounds or on the surface also. So that is the water equation or and everybody knows normally the water cycle is always in closed loop, and individually you see there is a system which is always running in a cyclic manner. So water is just moved from one storage type to another storage type. You can just apply law of equilibrium to the as a global unit. You find that there is nothing which is or receiving more or receiving less, but on a particular micro level there is a very significant changes, and now because of the climate change it is very disastrous also. Some parts in our subcontinent, in some parts we are having droughts, as well as some parts are flooded with water. So that is one more thing which is we are nowadays facing very frequently. The time of means recurrence intervals are very fast and very frequent. So that is one more term that every civil engineer should know, that reoccurrence interval. When we are working with a watershed development, uh, these are all synonyms of micro watershed. That means 500 to 1000 hectare landmass. 1 hectare is equal to 100 meter by 100 meter plot. That means 10,000 square meter. But micro watershed terms we are using for 500 to 1000 hectare watershed. And milli watershed is something more bigger. And in India there are 4 lakh micro watersheds. 7 to 2000 is milli watershed, that means 1000 to 10,000. Then sub watershed means 10,000 to 50,000, and according to that there are 35 different river basins, means so many rivers are there, and 6 regions in India. So this is all synonyms, or you can say the size is different, but the activity or the nature is or feature is same. And watershed means what? You can see the dotted line. This is a typical ridge area, and you just imagine that if there is a rainfall from a particular hillock, one slope is belongs to one watershed and another slope is belongs to another watershed. So for a particular stream at a particular point, the area which is catching the rains and uh, flowing from a common point, that is called, for that point, that is the watershed area. So it is a geographical unit and always changing with the point of contact. Watershed development is a program, it is a lifestyle even. So it is a concept for it, and it's an approach for sustainability also. Jal Yukt Shivar, Marathi में ऐसा कहते हैं जल युक्त शिवार. Shivar means the territory. It is a either it is a unit of village boundary or a forest boundary, whatever is there. The Shivar is full of water. Means that means it is a watershed development program. What is the objective of watershed development program? It is a very classical and very scientific approach of developing any certain geographical landmass. So very common sense also, that if we are doing something watershed activities in that particular geographical part, then it will reduce the runoff, means the rate of flow of streams or whatever the water is flowing, it will get reduced. Other one is because of the runoff is reduced, it will not carry so much of soil which is erosive in nature. So very silent killer if there is a soil erosion. Soil is made on the earth surface. Whatever the parent rock is there, in Malwa, it is basalt, means black igneous rocks. So the topsoil is in black cotton soil, which is a weathered form of that parent rock. So an average soil erosion of our country is almost 160 metric ton per hectare per year. That means almost 1 millimeter of soil is eroding every year with the rains or wind or whatever, all such natural means. And to create a 1 inch soil, it will take almost 1,000 years because of the weathering effect on the particular rock. So that is also one silent killer in respect of any farmer or any cultivable land. And because of that soil erosion, Gandhi Sagar Dam on which is very known in Mandsaur Neemuch area, it is silt up, and because of that, the effective lifespan is also reduced. So increase soil moisture, one also objective of that watershed development area. Make water streams perennial. If it is done with a very classical and scientific approach, your streams become perennial or flowing for 8 9 months. Increase groundwater level. If very common sense, if there is a water and it will stay on the surface, it will definitely percolate, because any small to large stream is run or taking path on the surface of the earth because of the weakness in the geology. जहां भी कोई नदी अगर बही है, कोई नाला या नदी, वो पाथ उसने वही लिया है जहां पर कि कोई ना कोई जियोलॉजिकल वीकनेस है, और वो जियोलॉजिकल वीकनेस पे अगर हमने कोई स्ट्रक्चर डेवलप करके वहां पर अगर स्टोर कर लिया उस पानी को, तो इट इज वेरी डेफिनेट कि it will help in recharge of the groundwater. Rejuvenate the plant flora and fauna. Very obvious. अगर जब वहाँ moisture profile of the soil is improved, then it will help to grow so many trees and plants, and because of that फ्लोरा और फौना भी रिवाइव होने वाला है. तो इनहेंस एंड एज वेल एज फार्मर के पर्सपेक्टिव से तो देखें अगर, तो ये वेरी ऑब्वियस कि प्रोडक्टिविटी भी उस लैंड मास की बढ़ने वाली है. दैट मीन इनहेंस इन प्रोडक्टिविटी ऑफ दैट लैंड एंड ओवरऑल सस्टेनेबिलिटी ऑफ द इकोसिस्टम. एंड द watershed approach is, or the principle of the watershed is from ridge to valley, मतलब चोटी से घाटी तक किया जाने वाला काम with different interventions is called watershed development program. There are so many interventions. Some are natural treatment, that means vegetative treatment, and because in our country watershed is, we are implementing for last 40 to 50 years. So it is a very long journey from that first day to till today, and we have so many experiences, so many successful interventions, so many persons carried out, and because of that there are so many different interventions according to the local. It is a tailor made approach. जहाँ जहाँ जैसा मौका वैसा काम. It is not a ready made approach कि सब जगह एक सही का ही काम होने की जरूरत है. इस तरह के काम किए जा सकते हैं. So there are so many interventions for a ridge area treatment, that means land treatment. CCT means continuous contour trench. Then there is some modification in CCTs, means trenches on the same contour line on the ridges. Now it is staggered contour trench, SCTs. That means because of the SCT, it is better because in the implementation, if there is any fault because of some person and it is not in contour, then it will enhance the erosion as well as the it will damage the whole concept. And contour bunds, farm bunds, bench terracing, drainage line treatment means boulder checks. The first gully plugs, the loose boulder gully plugs means boulder checks, and gabion structure Gabion structure may be wire mesh embedded stone structures. Normally boulder checks are constructed on at max 50-hectare catchment. It can handle only 50-hectare catchment of any drainage, the first order stream. But Gabion structures are handling up to 500-hectare catchment, and now the Gabions are also modified for used as a or constructed as a low cost check dams. And some nala bunds means earthen bunds or under earthen dams. Very technical intervention. And in drainage line treatment, some nala bunds, composite gabions, check dams, and even dikes, where the water is flowing for a certain time duration. Then underground subbase flows also can be checked, and because of that, in adjoining areas, the wells, dug wells, shallow wells can also be get recharged through these small and very economical structures. So these are some structures, and because of if there is a very classical way done, it will impact like that. The streams are full of water, wells are also recharged and having a good water levels, and because of the water is available, the second crop, even in this picture, it is a onion. Farmers are growing cash crops, vegetables, and even animal husbandry can be managed in this particular area where there the water is available. So this is a very classical picture of a developed watershed on for geographical way. And we are doing all these activities as a watershed development program. Some there are some thumb rules also developed as time goes. So more than 25% of the slope where there are some ridges and the landmass, and where there the slope of the ridge is more than 25%, that means the ridge area part, only plantation can be done, or it is suggested that only plantation can be happen or implemented on that particular area, because 25% slope, I'll explain in my later slides that how can we calculate the slope in percentage for a particular area by some barefoot tools. So on 10 to 25%, contour trenches can be allowed. Means SCTs or CCTs. SCTs means staggered contour trench. काट के बनाई हुई trenches, जिसकी वजह से damages can be localized or minimized. And जहाँ पर less than 10% slopes हैं, वहाँ पर contour bunds like farm bunds and all वो भी बनाए जा सकते हैं या can be constructed. And catchment area up to 50 hectares loose boulder checks means the gully plugs of loose stones placed in a proper manner can be constructed, or even earthen gully plugs where the stones are not available locally, so we go with the earthen gully plugs. There is a system how to construct all these, because earthen gully plugs is a very fragile structure. If there is a not proper exit weir provided, it will damage in a single rain. And the catchment area up to 500 hectares, we can suggest or construct Gabion structures, means wire mesh embedded structures. It can handle the 500 hectares catchment area runoff at a peak runoff level. Catchment area 30 to infinite hectare earthen nala bunds can be constructed. So many in India, there are so many different earthen structures are there, very effectively working for last 30 years. So earthen structure can be constructed in any catchment size. Catchment area minimum 30 to infinite. The check dams, which is in a hydraulic term, it is called overflow structure. Earthen nala bund is non-overflow type structure. Means water cannot allowed through over the that bund. So this is something different. Earthen dam as well as the check dam. And plain land, agricultural land, there are farm bunding, compartment bunding, contour bunding, and farm ponds. These are some interventions. Uh, I want to share one success story of Madhya Pradesh. That if you go through Google and find or search for what is the production of wheat, everybody knows that Punjab is the topmost producer of wheat in our country. But nowadays, Madhya Pradesh is on top because Madhya Pradesh government developed almost 23 lakhs of farm ponds in various fields of the farmer, and because of that the cumulative impact is like that the groundwater is improved, and because of that the second crop, that means rabi crop, and so many farmers are cultivating wheat. And Madhya Pradesh wheat is known for its quality, it is estimum. So रोटी बहुत सॉफ्ट होती है, सफेद होती है, बहुत अच्छी होती है, खाने में बड़ी मुलायम होती है रोटी हमारी। और जो ड्यूरम है दैट इज थोड़ा टफ होता है वो गेहूं, और वो दलिया में या इस तरह की चीजों में ज्यादा काम आता है, क्योंकि उसका जो ऊपर का स्केल है या उसके ऊपर का जो चमड़ी है गेहूं के दाने के ऊपर, वो थोड़ी सी हार्ड होती है और उसकी वजह से रोटी बहुत सॉफ्ट नहीं होती। तो देयर आर टू टाइप ऑफ व्हीट्स आर कल्टिवेटिंग इन आवर कंट्री, एस्टिवम एंड ड्यूरम। तो ड्यूरम ज़्यादा प्रेफरेबल नहीं होती रोटी ईटिंग एरियाज में, वो लोग ज़्यादा प्रेफर करते हैं, इसलिए हमारी पूरी कंट्री में एमपी व्हीट इज़ वेरी पॉपुलर एंड वेरी मतलब demanding. This is a classical sketch of watershed area. That means on the slope there are काट कर बनाई गई trench, that is staggered trench. और यही ट्रेंच अगर कंटिन्यूस बना दे तो इसको कंटूर ट्रेंच बोलेंगे, लेकिन कंटिन्यूस कंटूर ट्रेंच में सीसीटीज। These are some boulder checks on a first order stream, and then gabion, then mitti ka band, and then underground dikes and further check dams and all. हमारे country, and for that planning we need cadastral maps, means किसका खेत कहाँ पर है, नाला किधर से होके जाता है, कितना बड़ा लैंड मास है, क्या क्या करना होगा, as well as we need topographical map of survey of India on a scale 1:50,000। मतलब कागज पे 1 सेंटीमीटर इज इक्वल टू जमीन पे 50,000 सेंटीमीटर, मींस 50,000 सेंटीमीटर मींस 500 मीटर्स। तो कागज पे 1 सेंटीमीटर का लेंथ या साइज जो है वो जमीन पे आधा किलोमीटर का डिस्टेंस है। तो दिस इज द scale of that particular map which is commonly used in watershed development। यहाँ नीचे देख रहे हैं कि गांव वाले एक पीआरए मैप भी डेवलप कर रहे हैं कि उनकी समझ से कहाँ पर क्या चीज है, क्या करना होगा। So at the time of planning as well as in the implementation stage, every time the localites should be involved, so the ownership built in that particular program or project। अब जब हम बात करते हैं पानी की या रन ऑफ की, देन अब क्योंकि सिविल इंजीनियरिंग के सारे बच्चे हैं या स्टूडेंट्स हैं, तो देयर आर मैक्सिमम फ्लड डिस्चार्ज कैलकुलेशन मींस डेकन्स फार्मूला Q is equal to CA to the power 3/2, and rational formula Q is equal to CRA, and I means runoff, C means runoff coefficient, and A means area, and C is always depends on the land use. So type of soil, slope, as well as land use pattern के accordingly ये differ भी करता है. तो ये मैंने एक एग्जांपल के बतौर डाला है. ये नॉर्मली ये सारे कोफिशिएंट इस्तेमाल होते हैं रैशनल फार्मूले में, CRA वाले फार्मूले में, Q is equal to CRA. एंड आमने सामने होते तो शायद हम इसको एक्सरसाइज भी करते, but this is a typical topo sheet on 1:50,000 scale, and we are using for delineation of a particular watershed. So we want to delineate this watershed at a point of A. So इसे रीड्रॉ किया है सारी ड्रेनेज लाइन को, आप देख रहे हैं. This is the first image on the left top most picture. You just see, and then we redraw it, and the traverse is closed, and using this 1 millimeter to 1 millimeter type transparent graph sheet, if we superimpose it, it will give me the total number of these small 1 mm by 1 mm boxes or 1 centimeter by 1 centimeter boxes. And everybody knows that if the scale is 1:50,000 means 1 centimeter is equal to 500 meters. So 1 centimeter by 1 centimeter box, that means this one is equals to 500 meter by 500 meter. It means 25 hectare. 500 multiplied by 500 is equal to 25 hectare. 25 multiplied by 10,000, 250,000 square meters. This much, the only one box, and this one. And because of that, you can calculate how many boxes are there. So just multiply with the 25 hectare. So you will get the total acreage or total land mass of in hectares for a particular watershed. So this is very technical but very effective and accurate method of delineating any watershed area. Nowadays GIS is there, so no need to use this type of maps and all. And in the map it looks like this. Ridges also look like this, but the RL of that particular central part contour, central contour, is if there is a lower reading, then it is a valley, and if it is in higher side, then it is a ridge. So, and these are some barefoot tools which we are offering or using in our area. This is called A-frame type टूल. 3 बांस के डंडे हैं सिंपल 2-2 मीटर के, इनको आपस में ए फ्रेम की तरह बांध लिया है और बीच में एक प्लम बॉब भी लटकाया है, और इसका उपयोग हम कंटूर ड्रॉ करने के लिए वो पहाड़ पे. अब हर जगह हर समय हमें डंपी लेवल और थियोडोलाइट और ये सारी चीजें अवेलेबल होना मुश्किल है, और जीपीएस भी जो हमारे यहाँ गार्मिन के आ रहे हैं आजकल, कितना भी अच्छा इक्विपमेंट ले लो आप, उसमें 4 से 5 मीटर का मिनिमम लीस्ट काउंट होता है, तो वो बहुत एक्यूरेट नहीं होते. लेकिन ये बहुत ही बेयरफुट टूल है और बड़े आसानी से बहुत सारा काम एक साथ बहुत कम पैसे में बहुत सारे लोग एक साथ कर सकते हैं और बहुत एक्यूरेट भी है. तो इसका भी उपयोग करते हैं फॉर ड्राइंग कंटूर लाइन ऑन द रीजेस. जब पहाड़ पे काम कर रहे हैं और जैसे मैंने कहा कि स्टैगर्ड कंटूर ट्रेंच और कंटिन्यूस कंटूर ट्रेंच ड्रॉ करना है, उस समय पे इस तरह का इक्विपमेंट इस्तेमाल होता है. वेरी लो कॉस्ट, वेरी इजीली अवेलेबल एट एनी विलेज यू कैन गेट, एंड इवन इसको बना सकते हैं. तो ये एक और टूल है जिससे कि हम कंटूर लाइन ड्रॉ कर सकते हैं पहाड़ों पे. दिस इज हाइड्रो मार्कर, सिंपल. what the 1/4 mm plastic tube is used by any mason who is constructing wall or masonry work, वो इस्तेमाल करता है इस तरह की प्लास्टिक ट्यूब 1/4 सेंटीमीटर मोटाई की ट्रांसपेरेंट ट्यूब है, जो कि 4-5 मीटर की ले लें हम, और 2 लकड़ी के डंडे या लाठियां हों जिसके ऊपर हम स्केल ड्रॉ कर लें अपना टेप रख करके, मेजरिंग टेप, और नीचे 0 से शुरू करके ऊपर तक जहां तक भी है 2 मीटर में हर 1-1 सेंटीमीटर पे अगर इसका मार्किंग कर लें और इसमें पानी भर लें इस पाइप में लेवल ट्यूब में साइफन की तरह, और फिर इसको खड़ा कर लें और पास में एक जगह लाएं, देखेंगे आपकी दोनों जगह पे दोनों पाइप में वाटर लेवल या वाटर बबल, वाटर जो है वो एक ही सेम लेवल दिखा रहा है, अदरवाइज कि उसमें कोई एयर बबल ना हो उस पाइप में। और इसका इस्तेमाल करके हम स्लोप्स एज वेल एज कंटूर लाइन भी ड्रॉ कर सकते हैं। ऐसे 2 पॉइंट जहां पर कि इनका रीडिंग सेम है, दैट मीन्स द लेवल डिफरेंस इज 0, सो दैट इज अ कंटूर पॉइंट, मीन्स ऐसा कर सकते हैं। और अगर हमको स्लोप ड्रॉ करना है तो ये कैलकुलेशन भी दिखा ही रहा हूं मैं इसमें कि स्लोप इज मीन्स व्हाट, vertical interval divided by the horizontal distance in between 2 points। तो यहाँ पे हॉरिजेंटल डिस्टेंस हम दिखाना चाह रहे हैं, यहाँ पर है 5 मीटर, बट द वर्टिकल इंटरवल इज हार्डली 20.2 मीटर, सो द स्लोप इज 4%। 0.2 divided by 5 multiplied by 100 is equal to, and slope is always expressed in percentage। So ये एक और बड़ा आसान तरीका है कि हमको पता करना है कि हमारे यहाँ स्लोप क्या है या कैसा है। तो हर बार हमें डंपी लेवल या ऑटो लेवल या थियोडोलाइट और इस तरह के एक्सपेंसिव इक्विपमेंट मिलना भी मुश्किल है और अफोर्ड भी नहीं कर सकते शायद प्रैक्टिकली जब हम काम करते हैं बड़े स्केल पे। दिस इज वन मोर एग्जांपल ऑफ हाउ टू मेजर एनी स्लोप ऑफ ए ऑन अ रिज। ये दिख रहा है ए एक पॉइंट है, बी एक पॉइंट है, और इसके बीच में अगर कैलकुलेशन करना है तो ये हमारा तरीका है कि हम अगर वो हाइड्रो मार्कर रखें या इवन डंपी लेवल भी रखें तो उसमें जो स्टाफ में रीडिंग में फर्क है वो दैट इज वर्टिकल इंटरवल, एंड हॉरिजॉन्टल डिस्टेंस मींस टेकोमेट्री से हम निकाल सकते हैं जो उसका क्रॉस एयर होता है उसके ऊपर अपर स्टेडिया लोअर स्टेडिया उसका मेजरमेंट लेकर के उसकी रीडिंग का कैलकुलेशन करके 100 से मल्टीप्लाई करें तो हमको हॉरिजॉन्टल डिस्टेंस भी मिल जाता है। इस तरह के कुछ काम है जो कि वेरी प्रैक्टिकल और बहुत आसानी से किए जाने वाले हैं, बशर्ते कि हमें पता हो और हम कर पाए। फिर ये कंटूर ट्रेंचेस कैसे बनती हैं, दीज आर सम CCD नॉर्मली इन आवर कंट्री और इन आवर स्टेट 60 centimeter by 30 centimeter trenches can be constructed, and for that this is something calculations. This is a rational formula, Q is equal to CRA, where C is the runoff coefficient, Q is the quantum of daily rainfall. Always contour trenches are designed on a daily rainfall basis, on the doomsday where the maximum rainfall for a day, क्योंकि नॉर्मली हम देखेंगे कंटूर ट्रेंच में एक दिन से ज्यादा पानी दिखता नहीं है। आज बारिश हुई, 2 घंटे बारिश हुई, भर गई ट्रेंच, फिर वो पानी परकुलेट कर गया और वो खाली हो गई। आप 2 घंटे बाद जाएंगे देखने के लिए कंटूर ट्रेंच में पानी भरा है क्या, कुछ भी नहीं दिखेगा आपको, सब कुछ परकुलेट कर जाएगा। बिकॉज इन जियोलॉजी इट इज टर्म्ड एज और इट इज एक्सप्रेस्ड दैट कि सारे फर्स्ट ऑर्डर और फर्स्ट एक्विफर के जितने भी रिचार्ज पोटेंशियल है वो सारा रिजेस पे है। वहां पर हमारे 2 लेयर का ओपनिंग है, दैट इज रिचार्ज जोन। तो वहां पे छोटा भी काम अगर हमने किया है तो उसका इम्पैक्ट बहुत अच्छा होता है डाउनस्ट्रीम में नीचे ग्राउंड्स पे। तो इस तरह का ये कैलकुलेशन है, तो जिसमें क्यों हमें पहले तो पता करना है कि कितना पानी वो एरिया रिसीव करता है। तो Q is equal to C multiplied by R multiplied by A. A is the area of that particular range. और Q1 is, अब सारा ही पानी अगर हम हार्वेस्ट कर लेंगे तो नीचे कुछ भी नहीं बचने वाला है, ये नीचे कुछ भी नहीं जाएगा। तो वो जो अपस्ट्रीम डाउनस्ट्रीम का जो क्लैशेस भी हैं, कावेरी रिवर का जो विवाद चल रहा है तमिलनाडु और कर्नाटका के बीच में, उस तरह का बड़े स्केल पे फिर इस तरह का विवाद है। आज हम पाकिस्तान से भी लड़ते हैं या फरक्का बैराज में बांग्लादेश के साथ हम क्लैश कर रहे हैं, क्योंकि फरक्का बैराज में बनने के बाद से बांग्लादेश को पानी नहीं मिलता। तो इस तरह के इंटरनेशनली भी डिस्प्यूट्स हैं। तो हमारे यहाँ तो हम छोटे स्केल पे काम करते हैं, लेकिन ये भी एक विवाद है कि भाई अगर हम सारा ही पानी रोक लेंगे तो नीचे कुछ भी नहीं होगा, और वो उसके बहुत भयानक परिणाम है। तो इसलिए Q1 भी ड्रॉ करना है हमने कि हम केवल 70% ऑफ द टोटल रन ऑफ इज मैनेज थ्रू आवर इंटरवेंशंस, उतना ही हार्वेस्ट करेंगे, अदर देन बाकी हम जाने देंगे डाउनस्ट्रीम में। एक बहुत अच्छा हेल्दी तरीका है काम करने का। सो एंड लेंथ ऑफ कंट्रोल ट्रेंच मींस Q1 अगर निकाल लिया तो डिवाइडेड बाय क्रॉस सेक्शन एरिया ऑफ दैट ट्रेंच मल्टीप्लाइड बाय नंबर ऑफ फीलिंग्स। एक दिन में कितनी बार भरेगी वो ट्रेंच, बिकॉज ऑफ द क्वांटम इज सो मच। तो हम उस तरह से देख करके, और ये कैलकुलेशन सारे हैं और जो कि किए जा सकते हैं और बहुत ही इफेक्टिव है। So this is one example for a particular catchment area. We have taken all hypothetical 20 हेक्टेयर का एक प्लॉट है जिसका डायमेंशंस 836 मीटर बाई 239 मीटर का है, और वहां का एवरेज रेनफॉल वन डे का मैक्सिमम फॉर लास्ट 50 इयर्स 200 mm है, जो कि एक दिन में बारिश हुई है। और नंबर ऑफ फीलिंग्स हमें लगता है उस डेटा को देखते हुए कि 2 बार भरता होगा वो कंट्रोल ट्रेंच भरेगा, तो उसके अकॉर्डिंगली उसका इफेक्टिव जो कैलकुलेशन है वो हम निकाल सकते हैं। और उससे ये निकल के आया कि करीब 1.2 करोड़ लीटर्स पानी कैन बी रिसीव्ड ऑन दैट पर्टिकुलर पैच, मीन्स 12,000 क्यूबिक मीटर पानी है जो कि वहां पर हमें अवेलेबल है विद द rainfall if there is a rainfall of 200 millimeter. Then the length of contour trench का कैलकुलेशन भी है इसमें कि अगर ऐसा है तो 12,000 मल्टीप्लाइड बाई 0.7, यहाँ पर 12,000 multiplied by 0.7 means only 70% of the total whatever we are receiving is can be harvested. तो 12,000 का 0.7 means almost 8,400 cubic meter के लिए हमें प्लान करना है सब कुछ. Then the cross section, if our contour trench is 0.36, then and number of fillings is 2 times, then total number of meters or running length of a contour continuous contour trench is 11,666 meters. Just like that is a shallow contour trench, now it is in deep CCT, means 1 meter by 1 meter section. Same calculation is like same, but only the cross section is changing in that particular example. And the calculation for distance in between two CCTs is also can be calculated with this formula. D means distance in between two trenches. So the area divided by the length what we have calculated, अगर वो हम उससे ड्रॉ करें तो हमें दो ट्रेंचेस के बीच का डिस्टेंस भी मालूम हो जाएगा कि हमें जब उस पे लेआउट डालना है उस इलाके में तो किस तरह से उसका कैलकुलेशन है वो भी हमें करना आना चाहिए. एंड नंबर ऑफ ट्रेंचेस means the total length divided by the distance. So you can calculate how many number of trenches, a series, how many numbers we have to draw. तो वो भी निकल के आएगा कि यहाँ देखेंगे आप तो there are 14 rows of almost 239 meter length can be drawn on that particular landmass. So these are some examples of how to design and construct the contour trenches in a particular ridge area. This is a picture of staggered contour trench. जो मैंने कहा ना आपको कि काट के बनाते हैं, zigzag manner में होता है, बहुत इफेक्टिव है, वेरी लो कॉस्ट, और इसका डाउनस्ट्रीम में या डाउनस्ट्रीम पार्ट में लैंड मास पे बहुत अच्छा इफेक्ट है इन फर्स्ट एक्विफर. These are some more example of contour continuously staggered contour trenches. It is built like this. The width is 60 centimeter and depth is 30 centimeter. what is the do's and don'ts for constructing any contour trench? Very common sense. ऊपर वाले पिक्चर में आपको दिख रहा है कि ये बहुत सफाई से किया हुआ काम नहीं है, मट्टी भी बहुत पास में पड़ी हुई है और खुदा भी अच्छे से नहीं है, बहुत सारे जंगल में खुदा है और बहुत सारे पौधे भी शायद अप्रूट कर दिए उन्होंने। इस जगह पे काम तो सफाई से है, बट वट एवर द एक्सकेवेटेड मटेरियल इट इज पुट जस्ट एडजॉइनिंग टू दैट ट्रेंच। बड़ा कॉमन सेंस है कि जब बारिश होगी और ये इस तरफ से जब बह के पानी आएगा तो ये मिट्टी भी वापस स्लाइड करके इसी ट्रेंच में गिर जाएगी, तो इसकी इफेक्टिवनेस साल भर में ही बहुत कम हो जाएगी, सारा मिट्टी तो उसमें वापस आ जाएगी। सो वी शुड कीप berm, a safe distance from trench to the overburden और का excavated material के बीच में कुछ स्पेस छोड़ने की जरूरत है, तब ये इफेक्टिवली काम करेगी। ये देखिए आप, one more example, it is not a good work because overburden or excavated material is just put adjoining to that particular, and they have to plant something local species on that band also, जो कि इसमें नहीं किया हुआ और यही रिपोर्ट भी कर रहा है कि भाई ऐसा होना चाहिए। This is a good example of ridge area treatment, the plantation, local germplasm, वो करें तो फिर soil erosion ट्रैप हो सकता है। This is one more example of barren hillock is planted with some non-grazing species. ये आपको दिख रहा है जेट्रोफा, जेट्रोफा का प्लांटेशन है, नॉन ग्रेजिंग है, इसमें किसी का इंटरेस्ट नहीं है, इस वजह से ये सस्टेन भी किया और फिर इसके बीच में आप उस तरह के पौधे जो कि वहाँ लोकल अवेलेबल हैं वो लगा सकते हैं, तो ये रिज एरिया वापस हरा भरा हो जाएगा और जो बॉल्ड हेडेड बिल्कुल गंजी पहाड़ियाँ थी वो सारी वापस हरी भरी हो जाएगी। There are some example of contour bunds on the ridges where there the slope is not so steep. It is a very good intervention with very low cost. These are farm bunds on the farm fields and very frequent. So every हर खेत में पानी रुकेगा और जिसकी वजह से soil moisture improve करेगा. And these are the outlet, stone outlet constructed adjoining to the farm bunds. आप देख रहे हैं कि यहाँ पर काली मिट्टी का ये बंड है, लेकिन एक स्पेस भी प्रोवाइड किया है कि अगर ये फ्लडेड हो जाता है तो एक स्पेस है जहाँ से कि विदाउट डैमेजिंग दिस बंड इट विल गो और फ्लो विदाउट डैमेजिंग टू द bunds and all. These are farm ponds, dugout ponds, whatever you can say. जितना खोदेंगे उतना भरेगा, and normally it is known as 7 harvest structure because the first harvest is water, then soil, then if moisture prevail, then in drylands, in tribal areas, that moisture is used for cultivating chickpeas, मीन्स चना उगा लेते हैं उस मॉइस्चर के ऊपर। अगर पानी थोड़ा रुक गया तो इसमें पैडी कल्टीवेशन भी हो जाता है, फिश फार्मिंग भी कर सकते हैं। So there are so many interventions and because of such structures, और ये 5% मॉडल भी कहलाता है। If a farmer is having 1 hectare land, he has have to spare only 5% of his own land. 1 hectare means 10,000 square meters. हम उससे कहते हैं कि 500 स्क्वायर मीटर जमीन तो दे दे हमारे लिए कि हम तेरे लिए इस तरह का डगआउट बिल्ड करके देते हैं। ये अगर वहाँ कुआं है उस खेत में उस किसान का तो उसका रिचार्ज स्ट्रक्चर भी है, इसमें अगर पानी आके रुकेगा तो बट नेचुरली की परकोलेट करेगा क्योंकि हमारे यहाँ की जियोलॉजी भी उस तरह की है। पहले ब्लैक कॉटन सॉइल है, उसके बाद मुरुम है, उसके बाद में वेदर्ड सॉफ्ट रॉक है या वेदर्ड बसाल्ट है और देन कॉम्पैक्ट बसाल्ट। तो वो जो फॉर्मेशन है उसमें बड़े आसानी से रिचार्ज भी हो सकता है फर्स्ट एक्विफर। तो इस तरह के इम्पैक्टफुल स्ट्रक्चर है विथ वेरी लो कॉस्ट। These are the embankment type dugouts. So if we put the earth which is excavated from the stream and put on the downstream side and make a bund, so it will harvest. हमने 1000 क्यूबिक मीटर खोदा और पता लगा कि उसमें 5000 क्यूबिक मीटर पानी खड़ा हो गया because of that bund. So more productive, more cost effective, and cost benefit ratio is very high in such small structures, and these are constructed on the first or at max second order streams. So यहाँ पर बहुत ज्यादा मैनेज भी नहीं करना. अब हमें ये सिविल इंजीनियरिंग पॉइंट ऑफ व्यू से दिख रहा है कि ये सारा नॉन ओवरफ्लो टाइप स्ट्रक्चर है, मतलब इसके ऊपर से पानी अगर जाएगा तो एक ही मिनट में फूट जाएगा ये. देन वी हैव टू कंस्ट्रक्ट वन आउटलेट और एग्जिट वियर, एक सेफ पानी अलाउ करें हम, जिससे उस तरह का कुछ करने की जरूरत है. तो इट इज ऑल इन विद द कैलकुलेशंस. एब्रप्टली कुछ भी नहीं करना या कुछ भी नहीं किया जाता. इट इज ऑल कितना कैचमेंट है, कितना मैक्सिमम फ्लड डिस्चार्ज है, कितना हम हार्वेस्ट करने वाले और कितना अलाउ करेंगे बाहर जाने देने के लिए, यही उसके एग्जिट में से निकलेगा. उसको सबको ध्यान में रखते हुए एक प्रॉपर एग्जिट फेयर, उसका भी फॉर्मूला मैं बताता हूँ कि कैसे कैलकुलेट होता है, आगे आने वाली स्लाइड्स में वो दिखेगा. एंड these are the streams. So the sky blue color streams are first order stream. जब दो फर्स्ट ऑर्डर एक जगह मिलेगी, उसके बाद में जो डार्क ब्लू कलर है इट इज कॉल्ड सेकंड ऑर्डर स्ट्रीम. एंड जहां दो डार्क ब्लू मिलकर के पर्पल कलर आ गया, वो हो गई थर्ड ऑर्डर स्ट्रीम. सो these are the drainage network of a particular. When we are working for a watershed development, we have to know about each and every aspect of that particular landmass. So how many numbers of first order streams, what is the length or even drainage density, these are all technical terms which we can read in our textbooks, but what is on the field, how it can be applied for planning and designing of a particular watershed development plan, we have to know each and everything. And these are the general pattern in central India. फर्स्ट ऑर्डर स्ट्रीम मीन्स गली होगी, फर्स्ट ऑर्डर ड्रेन है, 0 to 2 हेक्टेयर उसका कैचमेंट होना चाहिए. नाली होगी जो कि सेकंड ऑर्डर ड्रेन कहते हैं, जब दो फर्स्ट ऑर्डर मिल गई 2 से 50 हेक्टेयर तक का कैचमेंट होगा. नाला होगा, थोड़ा सा बड़ा हो गया, दैट मीन्स 550 to 500 हेक्टेयर का कैचमेंट होगा. मीन्स अब थोड़ा बेड ग्रेडियंट मीन्स नाले का जो तल का जो ढलान है और स्लोप है वो भी धीरे धीरे कम होता जाता है या जेंटल होता जाता है. जो पहले ऑर्डर्स हैं फर्स्ट एंड सेकंड ऑर्डर, वहां पे थोड़ा सा स्टीपनेस ज्यादा होगी. मीन्स बहुत ज्यादा 1 मीटर का एक स्ट्रक्चर खड़ा करके बहुत सारा पानी नहीं, तो उस तरह का अंडरस्टैंडिंग भी होने की जरूरत है. फिर नदी है, हायर ऑर्डर स्ट्रीम मीन्स more than third order, fourth order, fifth order और even sixth order means नर्मदा नदी. बड़ी नदी है, बहुत बेड ग्रेडियंट बहुत जेंटल है, बहुत सारा बड़ा बेसिन है उसका, रिवर बेसिन, बहुत सारा पानी आएगा, उसको हैंडल करना थोड़ा मुश्किल भी होगा, ये सारी चीजें. तो मोर देन 500 हेक्टेयर्स इज अ बिगर स्ट्रीम इन कॉन्टेक्स्ट ऑफ वाटरशेड डेवलपमेंट. इन्फिल्ट्रेशन रेट के बारे में भी ध्यान होना जरूरी है कि मीडियम इन्फिल्ट्रेशन रेट मीन्स 15 to 50 mm per hour is medium and higher is more than 50 mm. So we are using this type of for these type of statistical data or to design even in the urban areas the roof water harvesting or वाटर रिचार्ज ट्रेंच और वाटर रिचार्ज शाफ्ट, वो सब कैलकुलेट करने के लिए कभी अगर मुझे मौका मिला और कोई टेक्निकल सेशन ही लेना है जो कि बिल्कुल ही कैलकुलेटिव और उस तरह का है, तो हम इस पे भी जा सकते हैं कि हाउ टू डिजाइन फॉर ए पर्टिकुलर कॉलोनी और पर्टिकुलर हैबिटेट, हाउ मेनी हाउसेस, हाउ मेनी रूफ्स, हाउ इज द पोटेंशियल ऑफ दैट पर्टिकुलर कॉलोनी और habitat. कितना रेन रूफ वाटर हार्वेस्ट कर सकते हैं हम, उस तरह के इसमें फिर कितना पानी हम जमीन के अंदर उतार सकते हैं, कितना पानी हम स्टोर कर सकते हैं और कितना पोटेंशियल बिल्ड हो सकता है। मैं शेयर कर दूं कि मैंने जलगांव जो कि 4.5 लाख की आबादी वाला शहर है, उसके लिए हमने प्लान किया था। तो करीब 57% ऑफ द टोटल वाटर ऑफ द ईयर इज अवेलेबल एट रूफ। इतना निकाला था हमने उसका पूरा टोटल हाउस बाय हाउस सर्वे करके। तो इतना जबरदस्त पोटेंशियल है हमारे छत पे, जो कि हमें पता नहीं है कि भाई कितना पानी आता है, कितना हम स्टोर कर सकते हैं। And these are some structures of this is a classical स्वाति मैडम ने दिखाई आपको, एक एवियन स्ट्रक्चर है विच इज कंस्ट्रक्टेड फॉर अ कैचमेंट ऑफ 500 एंड मोर के कैचमेंट साइज में। इसका पहला काम है कि ये सिल ट्रैपर है, मतलब बड़ा स्ट्रक्चर उसके अगर अपस्ट्रीम में बना हो तो ये सारी सिल्ट यहीं रोक लेगा, जो कि हम रीहार्वेस्ट भी कर सकते हैं हर साल। तो बहुत सारे जब जंगल में बनता है तो साथ में पत्ते भी आते हैं जो कि मिट्टी के साथ में मिलकर के सड़ जाते हैं। बहुत अच्छा खाद या ह्यूमस अवेलेबल है, जो कि आज हम देख रहे हैं कि सब लोग everybody is asking for organic material or organic food. So this is a source for that particular area, this type of structures ये मैनेज कर सकते हैं हम। फिर देयर इज सम मॉडिफिकेशन इन दैट गेबियन, एक इम्परवियस लेयर हमने अपस्ट्रीम साइड में डाल दी, तो ये इट इज वर्क लाइक ए लो कॉस्ट चेक डैम्स। पानी रोक रहा है, हाइट कम है, लेकिन इम्परवियस लेयर होने की वजह से पानी हार्वेस्ट कर रहा है वो, और पानी खड़ा हो जा रहा है वहां पे। द क्यूमुलेटिव इम्पैक्ट अगर ऐसे सीरीज में बने उस नदी पे या नाले पे, तो इसका इम्पैक्ट बहुत जबरदस्त है। टोटल हेड of water, तो hydrostatic pressure for that particular stream is enhanced and because of that बहुत सारा पानी रिचार्ज करेगा। और जो हमारी पुरानी स्थिति थी, स्वाति जी के एक प्रेजेंटेशन की एक स्लाइड में था कि एक महिला है जो कि सब बेस फ्लोज को भी जान रही है, समझ रही है कि सरफेस पे तो पानी नहीं है लेकिन जमीन के अंदर बहुत सारा पानी है, तो वो उसको पता है कि कहाँ पानी है, तो उसको क्यों ना हम और इनहेंस करें और उसको वापस सरफेस पे फ्लोज ले आए। तो इस तरह के काम करने की जरूरत है। फिर अर्दन डैम्स मीन्स अ वेरी क्लासिकल वेरी टेक्निकल इंटरवेंशन है ये वाटरशेड डेवलपमेंट का, because there are so many components which is designed with some calculations and even engineering का भी इस्तेमाल है। बहुत दिमाग लगा के बनाए जाने वाला स्ट्रक्चर है ये। These are all components for any civil engineer should know that cut-off trench, core wall and hearting, upstream and downstream slope, settlement allowance, and stone pitching on the upstream face of the earthen dam and top width of the embankment of that particular means that the head wall जो है उसका top width भी कितना होगा according to the height it will change, और बॉटम वेट कितना होना चाहिए, फ्री बोर्ड क्या होता है, एग्जिट वियर कैसा है, सरप्लस वियर जिसको कहते हैं वो कैसा होना चाहिए, रॉक टो कैसी है, हॉरिजॉन्टल फिल्टर टू गेट डाउन द सीपेज लाइन विद इन द स्ट्रक्चर वो क्या चीज होती है। बहुत ही टेक्निकल चीज है और बहुत वेरी लो कॉस्ट। एम्प्लॉयमेंट जनरेशन भरपूर है, जिस गांव में हम काम कर रहे हैं वहीं की लेबर काम करती है, बाहर से कोई मटेरियल हमें नहीं चाहिए। तो whatever the cost of development it is go into the rural areas, so that is one more beauty of this structure। और फिर इसका ये देखिए, अब इसमें कुछ मैंने फॉर्मूलेज भी डाल रखे हैं। top width of a earthen dam, it is all depends on the height of what you are planning for a particular structure's height. So 0.4 h means the height of the dam, maximum height of the dam, multiplied by 0.4 plus 1, that is the top width of that structure. And formula and this one more formula, that h by 5 plus 1.5, this is, and minimum whatever the minimum width should be 2 meters। तो इस तरह से है। and cut off trench कैसे होना चाहिए, तो अप टू द हार्ट डेटा, वेरी कॉमन सेंस, हमें तो beneath the structure we have to intercept the underground flows also, otherwise because of the uplift pressure, because of the reservoir which is created on the upstream side of the dam, it will give sand boiling on the downstream side और सारा पानी निकल जाएगा। तो इसलिए ये कट ऑफ ट्रेंच होना चाहिए, और कितना होना चाहिए उसके कुछ थंब रूल्स भी हैं और कुछ इंजीनियरिंग अप्रोचेस भी हैं या मेथड्स भी हैं उसको पता करने के लिए। हम स्कवरिंग डेप्थ कैलकुलेट करते हैं, स्कवरिंग डेप्थ आप लोगों को पता होगा, उसका कैलकुलेशन भी है जिससे कि हम उस कट ऑफ सीओटी जो है उसकी डेप्थ पता कर सकते हैं। सेटलमेंट अलाउंस कितना देना है, जब हम अर्दन स्ट्रक्चर बनाते हैं तो बहुत ज्यादा कॉम्पैक्शन या कंसोलिडेशन नहीं पॉसिबल है, क्योंकि हम रूरल एरियाज में रूरल डेवलपमेंट में काम करते हैं तो हमारे पास में बड़े बड़े इक्विपमेंट और मशीनरी नहीं होती जो कि बड़े इंजीनियरिंग के जो वाटर रिसोर्स डिपार्टमेंट करते हैं या बड़े कंस्ट्रक्शन जो होते हैं जिसमें शिप फुट रोलर एक मशीनरी है जिसका इस्तेमाल होता है। आजकल तो वाइब्रेटर्स भी आते हैं या कॉम्पैक्टर्स भी आते हैं, वो सब हमारे अफोर्डेबिलिटी के बाहर होते हैं। तो फिर क्या होना चाहिए, कॉम्पैक्शन तो हम करेंगे तो, लेकिन कितना उसमें सेटलमेंट अलाउंस भी देना है जिससे कि बाद में जब पानी गिरेगा और जमीन बैठेगी तो वो मतलब डैमेज या रिस्क नहीं क्रिएट कर दे उस स्ट्रक्चर के लिए। इस तरह का वो है। These are all the cross-sectional view of the earthen structure with so many technical components. ये कैसे होगा, कितना होगा, इसको क्या कहते हैं, ये सारा, ये सीओटी है जो ब्लैक कलर में दिख रहा है, ये कोर वॉल है जो कि इम्परवियस मटेरियल से बनी होगी। बाकी पूरा स्ट्रक्चर भले ही आप मुरुम से बना दें या परवियस मटेरियल हो, जो कि एक्चुअली these are all gravity structures. So because of their own weight, they retain water on the its upstream side. So उसका वजन भी इतना होना चाहिए, तो वो तो हम रेगुलर अर्थ से मैनेज कर लेंगे विद सेक्शन बढ़ा घटा करके, लेकिन जो इम्परवियस पार्ट है वो ये कोर वॉल और ये कोर सीओटी करेगी। और फिर अब हमारी तो कंक्रीट की छतें भी टपकती हैं, तो जब कंक्रीट ही इतना इम्परवियस नहीं है तो मिट्टी कहाँ से होगी, तो फिर उसमें से सीपेज भी जाना ही है। तो सीपेज लाइन को विद इन द स्ट्रक्चर ड्रॉ करने के लिए ये कुछ रॉकटोज एंड हॉरिजॉन्टल फिल्टर्स भी प्रोवाइड करते हैं जिससे कि पानी नीचे स्ट्रक्चर के विद इन ही हो, और वो कितना होना चाहिए, उसके क्या साइजेस होते हैं, वो सारे कैलकुलेशंस हैं। एमएफएल किसको कहते हैं, एफआरएल किसको कहते हैं, फ्री बोर्ड क्या होता है, और एग्जिट पियर का विड्थ कितनी होती है। तो इस तरह का ये देखिए, ये लाइव एग्जांपल है, पिचिंग यहाँ तक किया हुआ है, दैट मींस द उसके ऊपर का जो पार्ट है वो सारा फ्री बोर्ड है, और एग्जिट वियर ये उस डैम का एग्जिट वियर है जिसमें से कि जब ये फुल हो जाएगा तब इसमें से बह के जाएगा सरप्लस वाटर। दिस इज वन मोर फोटोग्राफ अलोंग द बंड, दिस इज द टॉप विड्थ, इस तरह के स्ट्रक्चर। तो ये इसके ये अपस्ट्रीम साइड में मतलब इस पार्ट में पानी भरने वाला है पूरा, और वो है उसका एग्जिट वियर। तो इस लेवल तक पानी भर जाएगा और उसकी वजह से डाउनस्ट्रीम में बहुत सारा ग्राउंड वाटर इंप्रूव करेगा। एंगल ऑफ रिपोज, वन मोर टेक्निकल टर्म। अब ये जो स्लोप्स हैं उस अर्दन डैम के वो कितने होने चाहिए, तो अकॉर्डिंग टू द मटेरियल यूज्ड फॉर कंस्ट्रक्शन ऑफ ए स्ट्रक्चर ये सब भी होता है। अब मैं दिखाता हूँ आपको, ये देखिए, ये नीचे जो दिख रहा है ये है हमारा एक क्रशर, क्रशर में ये गिट्टी गिर रही है और क्रशिंग होने के बाद में, और वो एक अपना एंगल रिटेन कर रही है, ये वहां पे स्टेबल है वो। इवन ये चींटियां जो हैं वो भी जब बाहर लेकर के आ रही हैं, अंदर उन्होंने अपना बिल या बाम्बी बनाई है और उसकी वजह से जो मिट्टी के कण ला के बाहर छोड़ रही हैं वो भी एक पर्टिकुलर एंगल पे है। या इवन ये सैंड है, दिस इज कॉल्ड द एंगल ऑफ रिपोज, जहां पर जाकर के अपने आप स्टेबल हो जाए। तो अलग अलग कोर्सर मटेरियल के लिए वो ज्यादा मतलब जेंटल होगा, एज वेल एज फाइनर मटेरियल के लिए वो ज्यादा स्टीपर होगा। तो इस तरह का इसका भी कंसिडरेशन हमारे कैलकुलेशन में या हमारे डिजाइन में या हमारे इम्प्लीमेंटेशन में हम इस्तेमाल करते हैं। डाउनस्ट्रीम एंड अपस्ट्रीम साइड का स्लोप्स कितने होने चाहिए वो भी सब कैलकुलेशंस हैं यहाँ पे, या दिख रहे हैं आपको। दीज आर ऑल थंब रूल्स, इतने साल से करते आए हैं, तो इस तरह के कैलकुलेशंस के साथ में ही उसको डिजाइन होता है। अगर 8 मीटर से ऊंचा अगर स्ट्रक्चर है, देन वी गो विथ द अपस्ट्रीम स्लोप इज 1:3.5, मींस 1 is the height but horizontal distance is 3.5 meter, so 1:3.5 के स्लोप में होगा। एंड डाउनस्ट्रीम इज ऑलवेज स्टीपर as compared to upstream, so that will one more thing we have to consider। ये देखिए आप, सीपेज लाइन जो है उसको, दिस इज सीपेज लाइन, तो इट शुड बी विद इन द स्ट्रक्चर। अगर ये स्ट्रक्चर के बाहर चली गई, दैट मीन्स हमारा स्ट्रक्चर बहुत तेजी से इरोड होने वाला है और डैमेज होने वाला है। सो वी हैव टू मेंटेन इट विद इन द स्ट्रक्चर। ये एक सिविल इंजीनियरिंग के स्टूडेंट को जानना चाहिए, वो ब्रॉडर पिक्चर। सो ये रॉक टो का क्या पर्पस है, वो ये सीपेज लाइन को जितना नीचे उतारेगा उतना हमारा स्ट्रक्चर सेफ होगा। आप इमेजिन करिए कि ये दिस इज नॉट देयर, अगर हमने ये कंस्ट्रक्ट नहीं किया और सीपेज लाइन हमारी यहाँ से निकल गई इस जगह से, तो ये क्या करेगी, ये वाला पार्ट पूरा इरोड करके धीरे धीरे पानी के साथ में बहने लगेगा और ये वाला पार्ट वेरी वीक हो जाएगा। और बिकॉज ऑफ इंजीनियरिंग हाइड्रोलिक कंस्ट्रक्शन या स्ट्रक्चर्स जब डिजाइन होते हैं, तो ये है उसका टो स्ट्रक्चर का, विच इज मोस्ट मींस वीक और डेलिकेट पार्ट ऑफ दैट पर्टिकुलर स्ट्रक्चर। अगर ये टो हमारा ठीक है, अगर यहाँ आप इमेजिन करो कि एक सीमेंट बांध है या चेक डैम है, और अगर उसका टो वीक है, तो हमारा ये ओवरटर्न भी हो सकता है या कोलैप्स हो सकता है स्ट्रक्चर। तो टो को रिस्टोर करने के लिए या उसको प्रोटेक्ट करने के लिए चेक डैम में हम एक टो वॉल बनाते हैं, आपने देखा होगा। और बिकॉज ऑफ दैट वॉल वो एक वाटर कुशन क्रिएट होता है पानी का, पहला पानी आया उस वाटर कुशन में भर गया, और वाटर कुशन क्या करेगा, टो में जो इरोजन्स हो सकते हैं, कि अब इमेजिन करो ये चेक डैम है और इसमें से ऊपर से पानी बह रहा है, क्योंकि वो ओवरफ्लो स्ट्रक्चर है, तो इसके ऊपर से अगर पानी बहेगा तो वो अपनी काइनेटिक एनर्जी यहाँ पे डिसिपेट करेगा, यहाँ पर उसका इम्पैक्ट आएगा और यहाँ वो खोदने की कोशिश करेगा। ये
एक्सक्यूज मी
बोलिए,
सॉरी फॉर इंटरप्शन सर, आपका एक्सपर्टाइज इतना अच्छा है दैट आई थिंक वी नीड अ डिटेल सेशन ओवर दिस, एंड because we are lacking in time, sir. We have a next session lined up at 2 p.m.
okay,
So
okay.
I request you,
Yeah,
sir, and
I'll finish in 5 minutes only.
Yes, sir.
Okay?
Thank you, sir.
Okay. So these are some pictures about the how to get your seepage line within the structure, and these are some calculations also to calculate the exit weir, how to calculate the exit weir of a earthen nala pond. And these are so one more formula, DC discharge, total discharge or discharge capacity of exit weir can be calculated, and it will be equals to the total flood discharge, means Q is equal to DC। ये करना है हमने, और इसमें लेंथ हमें, अगर हमने कोई एक फिजिकल पार्ट को अगर फिक्स कर दिया, देन इफ वी फिक्स दिस H मींस फ्लड डेप्थ, अगर हमने फिक्स कर दी तो हमें इस फॉर्मूले से L का कैलकुलेशन मीन द विड्थ ऑफ द एग्जिट वियर हम निकाल सकते हैं। बहुत आसान है, जो भी इसमें इंटरेस्टेड हैं बच्चे या जिनको आगे इसमें फ्यूचर बनाना है, उनको ये सब जानने की जरूरत है। So these are some calculations, and अब हम थोड़ा सा फेलियर्स देख लेंगे किस तरह से फेलियर होते हैं। हाइड्रोलिक फेलियर है, सीपेज फेलियर है, अर्थक्वेक फेलियर है फॉर अर्दन स्ट्रक्चर्स, और स्ट्रक्चरल फेलियर है। ये देखिए आप, इसमें अगर सीपेज लाइन अगर विद इन द स्ट्रक्चर नहीं रही तो वो ये करेगी, पीछे से टो वॉल को, टो पार्ट को इरोड कर देगी और स्ट्रक्चर हमारा फेल हो जाएगा। अगर हमारा फ्री बोर्ड बराबर नहीं है एग्जिट वियर में, तो ये स्ट्रक्चर मिट्टी का बांधा है और वो ओवरफ्लो कर जाएगा, उसकी वजह से स्ट्रक्चर फेल हो जाएगा। ये देखिए, ये सीपेज फेलियर है, ये धीरे धीरे, और ये कैसे हो गया, ये सीपेज फेलियर है, ये ऐसे हो गया, फिर ये ऐसे हो गया, और ये ऐसे हो गया। विद इन 3-4 आवर्स स्ट्रक्चर की ये हालत हो जाए। और ये बहुत बड़ा डैम है जो कि कैलिफोर्निया का फोटोग्राफ है, वहां पे बना हुआ कोई बहुत बड़ा स्ट्रक्चर, और फिर बाद में ये डाउनस्ट्रीम में ये हाल हो जाता है। ये देखिए आप, इसके ऊपर से रोड जा रहा है और ये स्ट्रक्चर आउटफ्लैंक हो गया अर्दन डैम। तो और जो मैं कह रहा था पाइपिंग बॉइलिंग, वो सब भी हो सकता है, या वो क्विक सैंड बॉइलिंग जिसको कहते हैं, वो ये है कि अगर आपने इसमें कट ऑफ ट्रेंच सीओटी अगर हम यहाँ डाउनस्ट्रीम में बना देते तो शायद ये वाली एक्टिविटी से हम बच जाते। ये देखिए, फ्लो फ्रॉम अंडरनीथ द स्ट्रक्चर, जिसको कि ये देखिए अब, ये सीओटी है, ये डायफ्राम टाइप है, ये वो हार्टिंग केसिंग जिसको कहते हैं वो है ये। तो अवेलेबिलिटी ऑफ मटेरियल के अकॉर्डिंगली ये बदल जाता है सब कुछ। और फिर ये छोटे छोटे स्ट्रक्चर्स हैं जो कि बहुत इफेक्टिव हैं। ये देखिए आप, जहाँ पर स्कोप नहीं है वहाँ पे फिर ये एग्जिट वियर भी मेसनरी में हो गया है, और नाउ फिशिंग इज देयर, फिशिंग एक्टिविटी भी की जा सकती है इन स्ट्रक्चर्स में। ये देखिए, ये झाबुआ का फोटोग्राफ है, मेरा ही बनाया हुआ स्ट्रक्चर है, और ये देखिए बनने के बाद ऐसा हो गया। ये गेबियन स्ट्रक्चर है, गेबियन जब काम करता है तो ऐसे ही सिल्ट और सारा जो ह्यूमस है उसको कलेक्ट करेगा। और दीज आर सम चेक डैम्स, वेंटिलेटेड स्ट्रक्चर्स है। और तो ये बहुत आसानी से होने वाला है, बहुत कोई रॉकेट साइंस नहीं है, लेकिन बहुत किस तरह के फेलियर्स हैं उसके बारे में भी अपन डिटेल में कभी एक आधा सेशन होगा तो हम बात करेंगे, या 1-to-1। ये कोरोना काल जिस दिन खत्म होगा उस दिन शायद हम आमने सामने बैठ के बात करेंगे तो ज्यादा अच्छे से एक्सप्रेशन भी दे पाऊंगा मैं, या डिटेलिंग भी कर पाऊंगा। तो ये अलग अलग स्टेटा वाइज बेयरिंग कैपेसिटी क्या है उसके अकॉर्डिंगली कंस्ट्रक्ट होते हैं, तो डिजाइन होते हैं। तो फाउंडेशन विड्थ कितना होना चाहिए इन, दिस इज इन चेक डैम। और ये फिर कुछ व्यवस्थाओं में बने हुए स्ट्रक्चर्स में किस तरह के फेलियर्स हैं वो देखा जा सकता है। यहाँ पे मैंने दिखाने की कोशिश की है कि ये जो फ्री बोर्ड है चेक डैम में, वो यहाँ से आउटफ्लैंक हो जाएगा, नाला यहाँ से निकल जाएगा। ये देखिए मटेरियल ऑफ कंस्ट्रक्शन किस तरह का यूज किया है, ये देखिए फाउंडेशन ही नहीं है इसमें, तो ये केवल ऊपर ही रखा हुआ है और अब ये इरोड हो गया है स्ट्रक्चर। तो ये कई सारी ऐसी चीजें हैं जो कि शायद की जानी चाहिए। ये मटेरियल ऑफ कंस्ट्रक्शन देखिए, अब ये सैंड हम इस्तेमाल करेंगे क्या, ये पूरा सिल्ट और सैंड मड है इसमें। ये देखिए आप, ये पेन रखा है, दैट मीन्स द, हम तो 20 mm मेटल या 40 mm मेटल की बात करते हैं, ये कौन से कितने mm का मेटल है जो कि कंस्ट्रक्शन में हम इस्तेमाल कर रहे हैं। तो ये देखिए, ये कोर्स एग्रीगेट है, ये नीचे वाला हैंड मेटल है ये, और कोई इसका वो नहीं है, मतलब ये स्पेसिफिकेशंस जो होते हैं स्टैंडर्ड, हाईएस्ट स्टैंडर्ड, उस हिसाब से नहीं। फिर ये कैसे कैलकुलेशंस होते हैं, ये अच्छा काम है। देखिए इसमें एंगल भी दिया हुआ है और बर्न भी छोड़ा है, दैट मीन्स वो ये अंदर नहीं आएगा। ऐसे कई सारी चीजें हैं जो कि देखने वाली। ये आदिवासी इलाके में देखिए, इनका कॉमन सेंस देखो आप, इन्होंने ये वाटर कुशन पहले बना लिया जिससे कि ये उसको क्योरिंग कर सके। तो ये बड़ा जैसा जहाँ मतलब ये एडाप्टेबिलिटी दिखाता है कि भाई इस तरह का काम होना चाहिए। तो एक आदिवासी है, ये मजदूर वर्ग अगर इस तरह से कर सकता है तो हमारे यहाँ पर बड़े जो कंस्ट्रक्शन हो रहे हैं उसमें क्यों नहीं करते। ये देख लीजिए क्वालिटी ऑफ कंस्ट्रक्शन। ये कहाँ बना हुआ है, ये चेक डैम मैदान में बना दिया। तो इस तरह के बहुत सारे, ये देखिए वाटर कुशन का साइज और लेंथ ऑफ क्रीज लेंथ जिसको कहते हैं, उसमें कोई तालमेल ही नहीं है ये। तो इस तरह का, और ये रवाइंस में बना हुआ बहुत ही सुंदर स्ट्रक्चर, और ये देखिए इसका इम्पैक्ट। इसके ऊपर मैं जरूर कुछ बात करना चाहता था, ये स्ट्रक्चर, क्योंकि सिविल इंजीनियरिंग के बच्चे हैं तो उनको जानना चाहिए कि ये आर्च्ड क्यों है और इसका क्या फायदा है। तो वो कभी मौका लगेगा तो मैं इस पे पूरा सेशन ही इस पे हम डिजाइनिंग पे बात करेंगे। तो ये आर्च स्ट्रक्चर है, इसमें मैंने हूप स्ट्रेस का इस्तेमाल किया है टू रिड्यूस द सेक्शन ऑफ द पर्टिकुलर स्ट्रक्चर। सेक्शन कम होगा, इट मीन्स कि अपने आप कॉस्टिंग भी कम होगी। तो ऐसी कई सारी चीजें हैं। ये देखिए अब उसमें हूप स्ट्रेस का इस्तेमाल किया, आर्च स्ट्रक्चर है, आप इसको हॉलो भी कर लिया। तो ये एक और मोर समथिंग न्यू इंटरवेंशन है, जो कि शायद हमारे नए सिविल इंजीनियर्स को जानना चाहिए कि भाई हम कैसे कॉस्ट कटिंग कर सकते हैं, कहाँ कर सकते हैं विदाउट कॉम्प्रोमाइजिंग विद द स्ट्रेंथ। ये देखिए, तो इस तरह का ये एक और आर्च स्ट्रक्चर है जो शायद स्वाति जी ने भी दिखाया ही था आपको। तो ये एक रिवर रिवाइवल की स्कीम के तहत हम बना रहे हैं अलीराजपुर में, नर्मदा की एक ट्रिब्यूटरी पे। तो ऐसे 14 स्ट्रक्चर बनने वाले। और ये मेरा कुछ काम इथोपिया में, जो मैंने वहाँ के ट्राइबल्स में सीमेंट की नॉन अवेलेबिलिटी के साथ में किए हुए स्ट्रक्चर्स हैं। देखिए आप, ट्रीटमेंट है ये, इसको आईब्रो ट्रेंच बोलते हैं। और ये प्लांटेशन का प्रोग्राम है उनका। और ये स्ट्रक्चर है जो कि डाइवर्जन डैम है, वो आसपास की पूरी जो हरियाली दिख रही है उस खेतों में वो सब, और ये सारे वहाँ के ट्राइब्स हैं जिनके साथ में हमने काम किया विदाउट अवेलेबिलिटी ऑफ सीमेंट। देखिए सारे स्ट्रक्चर जो तार जाली के ऊपर बैठे हैं, तो इस तरह के हैं स्ट्रक्चर्स। ये देखिए ये कंटूर बंड्स हैं, स्टोन बंड्स, और ये स्ट्रक्चर है। ये स्ट्रक्चर बाद में सीमेंट आ गया तो फिर हमने सीमेंट से भी बनाना शुरू किया। और ये मेरे सारे वहाँ इथियोपियन साथी हैं जो एक अर्दन डैम पे खड़े हैं। और ये वहाँ फिर एग्रीकल्चर एक्टिविटी, हॉर्टिकल्चर भी शुरू हो गई। ये बहुत मियाँ काजी यहाँ मैंगो, जिसके लिए जापान का मैंगो है, बहुत लाइमलाइट में है अभी, वो वहाँ बड़े मजे से हो रहा है। और ये कंटूर फार्मिंग, और ये अर्दन डैम। और बिकॉज ऑफ दैट डैम, ये देखिए इसका इम्पैक्ट, ये ग्राउंड वाटर, ये ओपन डग वेल है। ये सारी हमारी टीम है। थैंक यू।
So that's
That's all from our side.
Thank you so much, sir, for a wonderful session. Do the participants have any questions, doubts, or they would like to interact with sir?
Sir, I have a question.
Yeah.
Sir, actually, I asked about rock top. Sir, is there any guideline to design a rock top shape?
Sir, just 2 minutes more actually we are ending the previous section.
Hello.
जी मेरी बात हो गई। Hello, sir. I think sir has got disconnected. So, if you have any doubts, you can get in touch with me. We will convey to them. And thank you so much for this session. And I request you to get back on the Microsoft Teams platform for the next session. And I'm really sorry for the technical issue that occurred today. So, kindly forgive us for the lunch break, which we couldn't able to do. Please join back on the MS Teams platform. Good afternoon, ma'am. Shall we start, ma'am?
Yes, I'm absolutely fine.
Ma'am, we shall start. I'll just give an introduction and then we will start the session, ma'am.
Okay.
So I welcome you all to the day 4, session 3 of this AICT sponsored 1 week online short-term training program on water quality complication, restoration and environmental conservation of existing water bodies, Module 1, which is sponsored by AICT and organized by the Civil Engineering Department of IPS Academy, Institute of Engineering and Sciences, Indore. This session will be taken by Dr. Archana Kirti Chaudhary, ma'am. She is the Director and Principal of IPS Academy, Institute of Engineering and Sciences, Indore. IPS Academy Institute of Engineering and Sciences, Indore achieved this UGC autonomous status attributed to her efforts and guidance. We thank you, ma'am, for the wonderful efforts you have put. She is an enthusiastic researcher with various publications in journals, conferences, seminars, and workshops, 9 papers in international journals, 3 books, and 2 patents. She is a doctorate in civil engineering, postgraduate in water resources engineering with graduation in civil engineering. Enriched 23 years of teaching experience and 5 years of field experience. She also won Best Paper Award for monitoring groundwater fluctuations in part of Chhattisgarh at the 42nd Annual Convention of IWWA at Jodhpur. We are honored to have you with us, ma'am, today, and I thank you for taking out time from your busy schedule and enlightening us over the major issues. Thank you, ma'am. I request you to please start with the session, ma'am.
Okay. Thank you, Devanshi ma'am. Let me share my screen first and then just a minute. Okay. Is it audible and visible?
Yes, ma'am. Absolutely
Okay.
clear, ma'am.
Okay. Thank you, Devanshi ma'am. And thank you very much for giving me this opportunity to express my views regarding the optimizing use of surface and groundwater in an integrated manner. I think this is a matter of discussion. This is the need of today, that we have to be very careful about the use of either in groundwater or in surface water. The minimization or maximization in both the ways is challenging for us. So the basic objective should be optimize the use of surface and groundwater. And the most important thing, it should be in an integrated manner. Independently, it is very easy to handle the situation of groundwater as well as to deal the problems with surface water. But the problems what we are facing right now are, we have at some places there are access of groundwater, at some places there are access of groundwater availability. And we have to maintain the balance between these. And ultimately, we have to derive some policy so that we can decide how much percent of groundwater can be explored and how much we should be dependent on the surface water. So this is my small effort towards solving the problem. This is my suggestion. I worked during my PhD work for the same for the Chhattisgarh region. So I'm not dealing in detail about the Chhattisgarh region, but the general things I would like to discuss with you regarding how we can optimize the use of surface as well as the groundwater. Yeah, naturally, availability of water is not always granted. It is available in access. In some places, not available in access. Of course, it varies quantitatively in space as well as in terms of time. But we should remember always, it is a limited as well as a valuable resource. It is a renewable but a finite resource. It is limited and valuable. Optimally harnessed and used most beneficially under appropriate priorities of use consistent with the requirement. So this is the basically the objective. And to meet the increased requirements, that is to meet the increased municipal and industrial demand or the irrigation demand, the large number, various numbers of water resources projects incorporating, that may be a dam, maybe weir, maybe a barrage, maybe weir, and a network of canals have also been implemented. Some are the feeder canals, some are the receiving canals, and so on and so on. So we have a network of canals. But the improper management of water resources projects, there are some problems which are caused due to the water resources projects. So we have to solve the problems. Excessive irrigation, and which increase the groundwater recharge, which in absence of drainage often led to waterlogging problems. Because the area nearby the hydraulic projects like dams or rivers or barrages, there is a problem. Many times it is being facing by the nearby farmers of the nearby region, that the area get waterlogged. So that is not good for the irrigation purpose. That will reduce the irrigation capability. So in absence of canal irrigation, if there is no canal, we don't have a surface water, the entire demand is met by the groundwater, and the continuous withdrawal of water can lower the water table. So there are two extreme conditions. One is you have excess surface water. One is you don't have a surface water, and you are bound to explore the groundwater. Slides are not visible.
Ma'am, it's visible, but it's not changing.
This is the conjunctive use of surface and groundwater. This slide is visible.
No, ma'am, it's on the first slide only, the title slide.
Okay, let me think about it. Let me. इसको कैसे करूँ? Escape करूँ? No, sir. Huh? Okay. Now it is changing?
Yes, ma'am. Now it's
okay.
Absolutely right.
Okay. So there are two types of problems. One is one type of, okay, let me go slowly. This I have already discussed. Let me move to next slide and then relatively in the next time. So there are two extreme cases. One is you have excess amount of surface water that is nearby the hydraulic projects. Another type of problem where there is no surface water, you have to be dependent fully on the groundwater. Both are the extreme conditions. So future demand for the water requires planning maximum utilization of all existing supplies. Supplies from reservoir, groundwater reservoir. Groundwater is also a type of reservoir or the surface reservoirs. So your objective is to require planning for the maximum utilization of all existing supplies in an integrated manner, which can most economically be obtained by conjunctive use of surface and groundwater. So the conjunctive use of surface and groundwater, you can better define as a combined use of surface and groundwater. Due to the augmented water sources, higher water reliability can be achieved, or conjunctive use therefore functions as a buffer for the periods of water scarcity. The idea of this management approach is to use surface water when the water table is high and change to groundwater when the water table is low. This technique might be especially important as a buffer function for mitigating impacts of climatic change, such as increase of heat and the drought at the same time. It is combined and integrated. So the solution is the conjunctive use. That is, we have to keep balance between the use of two resources or two reservoirs, rather we can say. Conjunctive use is the combined and integrated management of surface and groundwater or optimally utilization of available water resources. It offers a great potential for enhanced as well as assured water supply at the minimum cost. It's one of the anti-waterlogging measures. It reduces the size of water resources projects. The combined use is now practiced, was not planned earlier, but came into existence being out of necessity. What exactly happened near the hydraulic projects, the area get waterlogged. If we explore the groundwater at the nearby region so that we can reduce the groundwater table, as we will be able to reduce the groundwater table, the irrigation is possible. And how can we reduce the groundwater table? Because if it is not required, there is excess amount of surface water. That's why groundwater table is very high near the hydraulic projects. So you can explore the groundwater and ultimately transfer to the hydraulic project itself. So you have to maintain a cycle, and ultimately you can reduce, you can overcome with the waterlogging problems, and we will be able to run the same hydraulic project. Otherwise, ultimately, after some time, the capacity of the reservoir or the capacity of the hydraulic projects going on gradually reducing. So there are one option: either you can construct another hydraulic project or another dam in series or succeeding site, or you can use the existing reservoir by maintaining a stable policy. In some portion of groundwater can be explored, some portion of surface water can be explored, and you maintain you derive a stable policy so that you can maximize the use of existing reservoirs. So this is basically the concept behind this. Groundwater simulation and various optimization techniques can be used together to explore management options. The problem of optimizing conjunctive use of surface and groundwater, it's very complex. It can be handled more conveniently with the help of tools of system engineering, because surface water, the movement of the water is in every direction. Three-dimensional model are you making, or multi-dimensional model you are making? That is again a big question. It's a big challenging for us. How you derive the objective function subjected to number of constraints. So there are so many system engineering options are available, which can be used for optimizing the conjunctive use of surface and groundwater. There are some models which were already developed in the past as simulation models, dynamic programming models, linear programming, non-linear programming, and many other models or non-conventional models are also in practice now. Now, basically, what are the limitations with this model? There may be advantages at some places, but there are some limitations with some models, with these models. The first one is the system approach and its framework of mathematical models. That is most widely used. There is no general algorithm. You cannot say for this dam, this algorithm results in a better way. At other places, the things may be different. Things depends upon the input data as well as the outcome you are expecting from the problem. Choice of method depends upon the type of system, the availability of data, and the most important, on the specified objects and the constraints. That was initially predicted by Ye in 1985. So for every problem, you have to set your algorithm and you have to find the results, that which one is possible, which gives you the best that you have to work out. The most popular one is the dynamic programming. It is very widely used for conjunctive use of surface and groundwater, but use of DP restricts the specification of the groundwater and surface water system to low dimensional representation of the system. This is the biggest restriction in dynamic programming. If we go for the simulation technique, this is also a good incorporate full-scale distributed parameters, groundwater simulation, into an agricultural management model. It allows comparison of specific strategies, but does not allow maximization and minimization of a particular problem. So if you're going for maximization and minimization, I think we should not go for simulation technique. Linear programming, the oldest one, the very elegant, rather restrictive in sense, but this is most widely used for these optimization techniques. Essentially requires objective functions and associate constant in the form of linear functions. This is basically the limitation in terms of decision variables. But even then, we are getting the result close to real by using linear programming, and relatively easy also to implement. Another one is non-linear programming. The most important limitation is slow rate of convergence of algorithm, and computer requirements are the major obstacles in the solution of large-scale practical problems. It arrives only local optimal solutions to most groundwater management problems, but not the final one. There are some non-conventional models are in practice which are giving the better results, or the results with the same as we got for the conventional models. So the people are shifting towards the non-conventional models. As by the Goldberg, called as the godfather of genetic algorithm. He actually introduced genetic algorithm. The structure of genetic algorithm differs from other optimization method in the 4 major ways. First of all, genetic algorithm uses the string coding of decision variables, not the decision variables themselves. This is the most important part. Using a string coding of decision variable, not the decision variable themselves. GA works with a population of point, not with a single point. It works with a population of points. GA uses the objective function itself, no derivative informations. And GA uses probabilistic, not deterministic search rule. So this is beneficial. This is more close to real problems. So GA provides an alternative to gradient-based technique for solving complex and highly nonlinear optimization problems. But the challenging part of GA is to formulate the objective function and the constraints as similar we are facing in the linear programming also. But the problems can be rectified. I will discuss later on in the remaining slides. Another approach is also being popular, that is artificial neural network. Most of the researchers are doing this because this is very easy to implement. Especially the feed-forward network has been successfully used for water resources, variables, modelings, and predictions. And this is even GA is also available on this MATLAB, and ANN tool is also available on MATLAB. People are using directly the tool for the optimization techniques. Ability to represent underlying nonlinear dynamics of the system model without any prior assumption regarding the process environment. But there is a limitation. We have an excess number of data. So there is no single comprehensive model developed for the irrigation of multiple crops, because usually the use of reservoir is also multiple, and the crops irrigation is also for the multiple crops, not for a single crop. So there is no single comprehensive model developed for irrigation and multiple crops in which reservoir operations and irrigation allocation decisions at field levels are integrated, and in which a conjunctive use policy for the irrigated area, apportioning the surface and groundwater components, taking into account the distributed parameter characteristics of the aquifer, soil moisture dynamics at the crop level is embedded. So there is no single comprehensive model, but we can divide the problem in components. We may use one algorithm for first part, we may use a second algorithm for second part, and we may use another type of algorithm for the combined one. So this is also possible. So there are 3 main components in conjunctive use. One is the surface water modeling, another is the groundwater modeling, and the last one is the combined use, that is conjunctive use modeling. So we'll discuss one by one each type of modeling. What are the favorable conditions in any type of modeling, either maybe surface or the ground. First of all, in surface water modeling, the most important thing which is required to be predicted is computation of inflow in the reservoir. Computation of inflow in the reservoir may be due to rainfall itself or due to monsoon region, the reason may be monsoon, or it may be the succeeding canal of it with some another canal or another reservoir may be feeding this canal reservoir also. There are some reservoirs which are directly not feeding the available to meet the irrigation or the MNI demand. Their outflow is basically the inflow for the succeeding reservoirs many times. So basically, computations of inflow in the reservoir is the most important thing. For a particular reservoir, the most important thing which we have to work out, whatever be the reason of the inflow, but important thing is how much is the inflow in that reservoir. Reservoir inflow rainfall on the irrigated area, crop water requirement, assessed from potential evapotranspiration and cropping pattern are the critical inputs to the model. So basically the inflow can be predicted on the basis of irrigated area. That is most important thing which is required, for which you have designed the inflow. Crop water requirements, obviously this will help you in determining the irrigation demand, demand of water from potential evapotranspiration and the cropping pattern. Evapotranspiration, this you can do predict with the help of, if you have less number of data, and there if you have specific information, you can use ANN. And cropping pattern are the critical inputs for the model. By changing the cropping pattern also, you can maintain the things. So the inflow, the requirement may be vary. The inflow series for reservoirs are computed based on basically the mass balance equation using the observed data. So the mass balance equation, input inflow is equal to outflow, and whatever the losses you have to work out. Another is stochastic inflow modeling, which is most commonly used. They are fitted to model the inflow. Time series analysis, of course, and modeling is an important tool in hydrology and water resources, which is most commonly used, most easy to use. Generation of synthetic river flow data is important in planning, designing, and operation of water resources system, because many times you don't have a sufficient data. So you have to generate the synthetic river flow data. Inflow series are used for the optimal operation of the reservoir. So the most important part of the system is to understand or to predict the inflow in that particular reservoir. Because everything before construction, we have to work out all these things. Then only you can utilize the maximum you can maximize the use of that particular reservoir. At the same time, for the existing reservoir, you can modify the situations. Now, GA models, GA use objective function information directly. Do not require its derivative or any other auxiliary information. That is used randomized initialization and a stochastic algorithm in their operation, and found to be suitable for solving reservoir operation problems. Nowadays, apart from linear programming, GA is most widely used for reservoir operation problems. So the condition is we have to have some constraints. This constraint problem can be converted into unconstrained problem in GA by introducing a penalty function approach. I'm not discussing in detail about GA, but just a brief about this. You can convert your problem into unconstrained problem by introducing a penalty function approach. The storage constants can be handled by using a penalty function approach. So this is very easily possible. Success of GA depends upon the choice of operators, their associated parameters. As per the Goldman, the godfather of GA, suggested that good GA performance requires combination of one. You must have a high probability of crossover. You must have a low probability of mutation. High probability means close to 100%. 1. Low probability of mutation, that means close to 0. And a moderate population size, usually minimum 100. And the termination should be, termination also you have to decide how, at what termination stage you want to find the result, because this is this is continuously working. So in I was using GA that 1000th generation termination point I was decided was 1000. So this you have to decide. Deriving general operating policy for the reservoir. So most of the reservoir systems serve multiple purposes. They are multi-objective in nature. And to optimize such a complex reservoir system, the dynamic programming, linear programming, nonlinear programming have been widely used in the past. These are the all conventional models. Nowadays, soft computing or artificial intelligence like ANN, like genetic algorithm, fuzzy set theory have arisen as an alternative to overcome some of the limitation of traditional method in the optimization and operation of storage reservoirs. ANN are applied on optimization result to produce optimal reading streams. Performance of ANN is evaluated for untrained data set. Ultimately, you have to train the data. MLP is also being developed using training data. So ANN proves to be a better alternative for generating operating policy for a multi-reservoir system. And this is the most easy one. If we are planning to go for research, I think this is the best way. Groundwater, this is one of the parts. So ultimately, the point of concern is you have to decide the inflow series. You have to decide the quantum of water, the availability of water, the inflow in a particular time in a particular region. And the inflow varies with time and space, of course. So this you have to work out by using these models. Now, because you have to optimize both the things, the ground available water as well as the surface water. So now the other major component in the conjunctive use is groundwater. So groundwater modeling, the objective is to predict the response of the system in form of groundwater hats, which can be fulfilled if hydraulic conditions are defined precisely with some assumptions. Because we have to fix some assumptions on the basis of this, you can start modeling. Before we start for the groundwater modeling for prediction, it should be calibrated. You should calibrate the model. We should model the groundwater fluctuations. we should model the groundwater discharge assessment. So this we have to work out. A mathematical model consists of set of differential equations that govern to the flow of groundwater. Now, what exactly the mathematical model lookouts? It's a set of differential equations that will govern the flow of groundwater. So the most important part, the most challenging part is to set the differential equations. The reliability of production using a groundwater model depends upon how well the model approximates the actual flow condition, how close to the real problems, how you are close towards the real situations. So this is again a very challenging part. And because of the complicated field situation, simplifying assumptions, however, always need to obtain the mathematical. When we are going for the research, we have to first decide that, okay, if this is the assumption, then this model is giving you the better results. The assumptions may be the flow is treated as two-dimensional flow system. It is a limitation in modeling because flow is not always two-dimensional. One aquifer system is modeled with only one storage coefficient, that is only in vertical direction. Aquifer is bounded at the bottom by impervial layer. If it is not bounded by an impervial layer, whatever you predict, whatever you model will not be correct at all. The upper boundary of the aquifer is either an impermeable layer, that may be confined aquifer, or slightly permeable layer, that is semi-confined layer, or a water table, that is unconfined aquifer. Darcy law, head loss varying linearly with the apparent velocity of flow. This should be valid, and Dippett's assumption, whatever the Dippett's assumption, that is negligible vertical flow, we are considering. Because it is not possible that there is no vertical flow. The aquifer has head control, flow control, zero flow boundaries. First of these boundaries may vary with time to time. So the important thing is the process of infiltration and percolation. Infiltration and percolation of rain and surface water and of capillary rise and evapotranspiration taking place in the unsaturated zone of aquifer cannot be simulated. This means that net recharge to the aquifer must be calculated separately and prescribed in the model. Now, in short, the important thing is with the given infiltration, what is the response of groundwater that you have to work out. Now, there are two major ways. First, with the help of given set equations, with a given trend, you can fit some equations, and accordingly, you can predict the groundwater for the future. This is one of the way. Another way, with the existing water table, you have to derive the equation. Sorry, with the given equation, you are deriving the outcome, or with the given outcome, you are deriving the equation. So there may be inverse or direct problem of groundwater modeling. So groundwater modeling is essentially a forecasting problem where the solution of the equation governing the flow of water in an aquifer is solved. This is one way. To obtain the solution appropriate, initial and boundary conditions are imposed with the known aquifer parameters. Now this model, once we develop the model, so ultimately with the given inflow, with the given groundwater flow, you can derive the equation and you can predict it, or you're having the given equation and you can predict the future. So the model can then be used to simulate the response of the aquifer to any excitation. This may be in the terms of pumpage, it may be in the terms of recharge, it may be in the terms of recharge of a change in the boundary conditions. Response would be in the form of either the water table fluctuation or a stream aquifer interface. Both the things are possible. The most difficult and the challenging part in the mathematical modeling of groundwater is collection of data relating to spatial distribution of storage coefficient, specific yield or transmissivity. Both the things, it is a very difficult part. The most widely used method of determining aquifer parameters is known as a pumping set. Aquifer parameter represent only that the portion of the aquifer which lies within the radius of the influence of the well used for the pumping test. This is again one of the major limitations. So model should be first calibrated against historical data. The calibration process invariably requires the adjustment in the aquifer parameters, of course. Estimation of these parameters is thus an inverse process where these parameters are calculated from the historical excitation response and the associated initial and boundary conditions. So system in this case be represented by the equation correlating the response to the excitation, which is most important part of the system. So in short, if I can say the groundwater modeling is groundwater discharge assessment. You must have a modeling for rainfall infiltration factor. And what exactly is the net groundwater availability? It depends upon the annual replenishable groundwater resource minus natural discharge during non-monsoons. I will show you in short, explain you with the schematic diagram for this. So conjunctive use basically implies the planned and coordinated management of surface and groundwater. So there are two types of modeling is over. First part is the surface water modeling. Another important phase is the groundwater modeling. Now the ultimate part is you have to optimize the use of A and B, that is surface and groundwater, and finally recommend some policy by using the surface as well as groundwater in an integrated manner. So this implies the planned and coordinated management of surface and groundwater so as to maximize the efficient use of total water resources, total existing water resources, more precisely we can say. Because of the interrelationship existing between the surface and subsurface water, it is possible to store during critical periods surplus of one to tide over the efficient of the other. So this can be made, we can maintain the balance for this. This groundwater may be used to supplement the surface water supply, to cope with the peak demands, to meet the municipal and irrigation purpose, and to meet the deficiency in years of low rainfall. So this groundwater is always be considered as a supplement, not the main source. On the other hand, surplus surface water may be used in overdraft area to increase the groundwater storage by artificial recharge. So moreover, surface water, groundwater, or both, depending on the surplus available, can be moved from water plentiful to water deficient. So at one place you have an excess water, at one place you have a less water, at one place you have a lower groundwater table, at one place you have a higher groundwater table. So you can transfer this. How this is possible? How this is not so easy that we can pull it on a train and shift it. It's a biggest issue because you have to train the area, the nearby area. We have to train the user so that they should be dependent on the groundwater. Even they have access surface water, but they should be dependent on the surface water, groundwater, or the vice versa is also possible. Moreover, surface water, groundwater, both depending on the surplus available, can be moved from water plentiful to water deficient areas. On the whole, the integrated system correctly managed will yield more water than separately managed surface and groundwater. So ultimately, your objective is to improve the irrigation capacity. Ultimately, your objective is to minimize the expenses to meet the M&I demand and the industrial demand, municipal and irrigation demand, industrial demand, and the irrigation demand of water. So conjunctive use has been defined in more ways than one, but in general, if we can understand, it is defined as allocation of surface and groundwater in terms of quantity as well as quality, so as to achieve one or more objective while satisfying certain constraints. This is basically the precise definition of conjunctive use model. And the model can be defined, characterized by three main components, which I've already discussed: the reservoir, the irrigated area, and the underlying aquifer. The reservoir may be of any type. Obviously, the multi-purpose reservoir we are discussing, and the underlying aquifer with the associated dynamic relationship determining the interaction between them. This you can better understand by the schematic diagram of conjunctive use. We have one reservoir. I am discussing only for a single reservoir. There are certain challenges in which we have multiple reservoirs, more than one reservoir at a time, and you have to deal the same problem. And in that network, it is very complicated because the release of one reservoir may be the inflow for the another reservoir. At the same time, there are certain losses, so that has to be worked out. During my PhD work, I did the same. I have a problem with 6 reservoirs at a time for a particular region. But I am showing you the schematic diagram for a single reservoir. This is the reservoir. Actually, this is the inflow in that reservoir. Reason may be anything. Okay, this is a downward flow. This is the release to the irrigated area. So this is a regulated release. It depends upon the demand of irrigated area, right? Now, at the same time, the limitations of the reservoir. Whatever be the demand, if you are unable to provide from reservoir, ultimately you have to dependent on the other agency also. At the same time, while from reservoir to irrigated area, there is some canal recharge. So there are some canals used for recharging purpose for the aquifer, right? Now, aquifer can be recharged, and as well as you have to maintain the pumping. Now, the best water modeling, groundwater modeling is you have to explore the water by pumping maybe close to your recharge, so that your groundwater table will remain same. You are exploring the groundwater table up to a certain extent, and the extent will be decided based on the recharge. So, utna hi you can explore, you can pump out the water so that you will be able to maintain the groundwater table. So, this is basically the basic thing to be concerning thing while deriving the model or while formulating the model for the groundwater. So up to what extent you can pump out the water so that you will be able to maintain the groundwater table. The pumping should be more or less close to or equal to recharge. Now this is the irrigated area. Irrigated area will get the water by rainfall also, but this irrigated is fed by the release of the canal as well as by the groundwater. Now there may be certain problems. There are some areas in which we don't have a sufficient amount of groundwater. You are unable to explore the water from groundwater. Or there cases maybe you don't have a surface water. You have to be fully dependent on groundwater. Now, if we maintain the balance, if you have excess amount of water, but even then you can release up to a certain level, and you will be dependent on some up to certain extent to the groundwater, then you can maximize the outcome. This is basically the objective of conjunctive use or optimizing the use of surface and groundwater. At the same time, in an irrigated area, there is a rainfall. There are some losses that is actual evapotranspiration, and which is the most important part of concern. This we have to work out well in advance for any type of flow. And the now the important part of the system in the modeling is you have to work out the irrigated area. For that irrigated area, what exactly is the demand? So whatever is X is the demand. So X demand can be fed by X1 or X2. X1 may be released from reservoir, X2 may be released from the groundwater. How much X1 can be released, utilized, how much X2 can be utilized, this is the matter of concern. Now, the deterministic linear programming has been most widely used optimization technique in conjunctive use modeling. Now, what exactly you have to, I'm saying that you have to maintain, you have to decide what is X1, what is X2, how much X1 we can explore, how much X2 we can explore. So the policy for which annual change in groundwater table is negligible for a normal year is considered as a stable policy. That is a stable policy. And your objective is to derive the stable policy. The derived stable conjunctive use policy adds in planning the total crop water allocation for the irrigation. Again, genetic algorithm is to maximize the sum of relative yields of the crop given inputs of the reservoir storage at the beginning and the end of the season. The model takes into account the intra-seasonal competition of water among multiple crops, soil moisture dynamics, everything related to, and the heterogeneous nature of the soil and crop response for the level of irrigation applied. Because soil is not always homogeneous, the behavior of soil, the percolation, the infiltration, everything is varying. So this also should be taken into consideration. Now, ultimately by modeling in three phases, one is the surface water modeling, another one is the groundwater modeling, and finally by using the conjunctive use modeling. You can use conventional model in surface water modeling. You can use conventional model in groundwater modeling, and the combined combined input will be the modeling for the conjunctive use modeling. Or independently or collectively you can use the same model, or you may use some conventional method, because inflow is very easily modeled by non-conventional method. You can use this. You can use non-conventional method for groundwater modeling also. You can have conventional and non-conventional modeling combination for conjunctive use model also. So it depends on, totally depends on you, and the data pertaining to the model is also required. So whatever the type of data you are having, that is the most important thing. It is a matter of concern. If you have excess amount of data, train the data, and here is the best way. So the particular policy for which annual change in the groundwater storage is negligible when the model is run for a normal year is identified as a stable policy. Higher proportion of groundwater allocation may increase the annual crop yield, but at the expense of a declining water table. So this should not be taken into account. Obviously, you may increase the demand, but if your groundwater table is declining, that is not at all suggested policy, because your matter of concern should always be groundwater table should be maintained properly. This should be given the top priority. So whatever the excess water, you have a particular level, whatever excess is recharged, that can be pumped out. You should not disturb the groundwater table for a particular region for the long-term solutions. On the other hand, if increase in portion of surface water allocation causes an increase in groundwater table, which may lead to undesirable waterlogging condition in the long run. The stable conjunctive use policies identified above will be used as a planning in irrigation allocation. So this is from my side. Now, before thank you, I would like to add something. Like, there are some advantages and some disadvantages of every type of modeling. If you are going for the conjunctive use of modeling, ultimately the advantages is you improved security of water sources rather, protection of groundwater table, reduced environmental impact. Because whenever you're going to construct another hydraulic project, ultimately there's something you're disturbing the environmental balance. So reduce environmental impact. At the same time, it is not very easily, it's very expensive matter to have a additional hydraulic project. So the best way to use the existing hydraulic projects. Increase of agricultural productivity. Of course, these are the major concerns, major advantages which you are getting from conjunctive use. But the disadvantage is it's a complex implementation. It is very complex implementation because first modeling is ultimately a very challenging job for us, and with the various assumptions we are modeling the concern, that is not exactly close to real. This is the most important constraint. Another important thing is a very complex method in groundwater as well as surface water, groundwater. And another important thing is benefits, whatever we are getting is only for a long run, not for a short run. Whatever you see the benefits of conjunctive use is a long-term policy. It should be a long-term, visible for the long term. So the point is, initially you will not get any advantage in the short duration of time. It is difficult to convince the people. It is difficult to convince using, you have to be, he is very much comfortable with surface water and convince him to use the groundwater or the vice versa. It's again a big challenge for us. And because he will not understand the benefits, because the benefits will be coming in a very long time. So these are the limitations with conjunctive use policy. This is from my side. Thank you. Now, I'm most welcome for any question.
Thank you, ma'am, for a wonderful presentation.
Thank you.
Are the participants having any doubt? You can type in the chat box, or you can come online. Ma'am, I have a question.
Yeah.
Ma'am, actually, there's a lot of algorithm and this type of computer-based modeling which was previously being studied. But these days, ma'am, there are a lot of emerging remote sensing tools as well. So how can we relate to those things, ma'am?
No issue at all, madam. Ultimately, with the help of remote sensing, you will get the data. Your objective is to optimize the things, outcome. You're not getting the outcome. With the help of remote sensing, you will derive the data. That is okay, easily available at all. But ultimately, getting the data is not only the problem. That is obviously a big challenge. May I stop sharing?
Yes, ma'am.
Okay. So the basic objective is not only to get the data. The basic objective is to optimize the data, what we are having, or you have to optimize the outcome. You have to change the pattern of use of water. And how to optimize the data, then I think remote sensing is a very good, it may be helpful for us, but for deriving the data, I think so. Yes. And at the same time, the most challenging part is the main weakness we can say of conjunctive use is high complexity. And strength is improved sustainability of groundwater resources. Because ultimately we have to shift towards the sustainability. And reliability factor, if we consider only reliable if monitoring and coordination is well done. In the country like India, monitoring and coordination, we are suffering only because of monitoring and coordination between the different agencies. Ongoing monitoring and adaptations are needed. At the same time, adaptations is also very challenging task for us. Special knowledge is required. Otherwise, groundwater sources may be going on exploited, what we are seeing right now.
That's absolutely right, ma'am. Thank you so much.
Thank you.
Ma'am, I have also a question.
Yes.
Yes, ma'am.
I love to answer your question.
Ma'am, actually, the single reservoir optimization is easy.
Yes.
But ma'am, madam, how for cascading reservoirs are more than 2 or 3 reservoirs are there, then how we optimize?
No, it is a difficult job. I understand. In my research work, I use 6 reservoirs at a time. Yes, that was a complex of reservoirs. That was a mall, it is a complex. So my problem was a MRP complex, Mahanadi Reservoir Project Complex, where 6 reservoirs were there. 3 were the feeders, 3 were the kuch canals the, kuch feeder canals the, kuch reservoirs the. Yes, independently, ultimately, from the very basic, जब आपके पास multiple reservoirs हैं at the same particular area, है ना? So multiple reservoirs, there may be final reservoir. There are 3. In my problem, there were 3 reservoirs which are directly feeding to the irrigation area, right? So that was the problem. So that ultimately we have to decide how much inflow should be transferred to which reservoir. And 3 reservoirs are for the feeding for these reservoirs. Actually, क्या problem है? Initially, if there was a single reservoir, so single reservoir, because ultimately reservoir is reducing the capacity, so you don't have any option. Your requirement is going on increasing day by day. So if your demand is increasing and the capacity of a particular reservoir, you cannot increase the capacity of the reservoir. If you have enough capacity of the reservoir, there is no need to have multiple reservoirs, because if your one reservoir is not able to feed the canal. It's a very simple way I can explain you. You have 6 tanks in a line, or 6 tanks with different lines. Now, what you have to decide for meet a particular demand? This much reservoir is required X1 quantity of water. Another reservoir required X2 quantity of water. Another reservoir required X3 quantity of water. Now, X2 quantity of water, the requirement, there may be possibility you can issue equal amount of water to all of them. Now, you have to feed that X1 reservoir frequently. You have to feed X2 reservoir not so frequently. You can feed X3 reservoir not so frequently. The feeding may be variable. This may be possibility. But the point is, if ultimately आपने क्या करा, water लिया and you are shifting to X1, X2 and X3 by an equal amount, ultimately the X2 reservoir is not, the requirement is not like that. है ना? अगर X2 की reservoir कम है, it is not frequently being used, and if X2 reservoir का nearby area is waterlogged, why not you reduce the capacity of X2 and train the users to explore groundwater so that you can maintain them. So ultimately, you have to derive the operating policy for each reservoir. Yes. At the same time, you have to decide the groundwater table of that particular region. And then finally, you can suggest the solution. Yes.
Thank you.
Anybody else, I think, having some question?
Yes, anybody from the participants would like to interact? I think Mr. Mohit Satani sir was trying to come online. Mohit sir?
Sir, I'm unable to hear you. I'm sir, kindly repeat, sir. I'm sorry, I'm unable to hear you properly.
Yes, Mohit sir, do you want to have any question answered? Because we couldn't hear you properly. Maybe there's some network issue at his end, ma'am. So anybody else from the participants? So I don't have any questions raised in the chat box, ma'am. I thank you so much for taking out time from your busy schedule and giving us such a knowledgeable expert session. I'm highly privileged and obliged that you agreed for the session, ma'am. Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you.
Thank you,
Lalitesh,
ma'am.
you come to contact me. I will be really happy to guide you for this purpose.
Yes, ma'am. Yes.
Okay.
Thank you.
Thank you.
Thank you so
Thank
much, ma'am.
Thank you. Thank you. Thank you, everyone. Thank you.
Thank you.
So the participants, since we didn't have a lunch break, we will be dispersing for around 20 minutes and we will be getting back at 3:15 for the next session. And I hope to see you soon. Thank you.
Good afternoon, everyone. Now we have started session 4 of day 4 of our STP water quality complication, restoration and environmental conservation of existing water body, module 1. Now with us Associate Professor Divyanshi ma'am, who have many achievements, coordinator of IIRS ISRO Distance Learning Program, Department of Space, Government of India, Dehradun, 16 years of professional expertise, former project scientist, NIRI, Nagpur, former assistant professor at Medicaps University, Indore, won Session 2015 Award for Energy, Environment, Ecology and Society BE 202, won Best Oral Presentation Award at ICMN 2020 International Conference, Multifunctional Nanomaterials ICMN 2020, organized by Department of Physics, Manipal University, Jaipur, 28 to 30 December 2020, won Research Excellence Award 2020 by INSC Bangalore, 24 research publications and 4 books. So now with us, Dr. Divyanshi ma'am, over to you, ma'am.
Thank you, sir, for the lovely introduction. I shall share my screen now. I hope the screen is visible to you, sir.
Yes, ma'am.
Okay. So we start with the session 4 of day 4, and the topic shall be emerging trends in wastewater treatment. So we are very well aware that this program is sponsored by AICT and organized by the Civil Engineering Department of IPS Academy, Institute of Engineering Science, Indore. The water is the basic source of life. This is a very well evident fact, and we know this, that we cannot live without water. We can survive without food, but we cannot survive without water. The major reason being that our body is completely, majorly made of 70% of water. So water is the basic source of life for human survival and all forms of living creatures on this earth. Now in 2010, it has been established that everybody has the right to have proper quality of water. So the access of water is being declared as the fundamental right for all living organisms. So humans have the right to have water, not only in sufficient quantity, but along with that, the water should be safe, it should be acceptable, it should be physically accessible and affordable as well. That means not only that we should have water in sufficient amount, but along with that, that water which we are getting for consumption should be safe, it should be acceptable, it should be physically accessible and as well as affordable. So for these reasons, it is necessary to have a proper supply of water for humans, which we use on day-to-day basis. So there are varying words resources. I hope I'm audible and clear, that my screen is also clear. And if at any point, if you're unable to hear me, please let me know.
It's audible, madam.
Thank you, sir. Thank you, sir. So the world's water resources are in various forms. They are oceans. It is available in atmosphere in the form of water vapor. We have rivers and streams. It is also available in the form of groundwater, lakes, ice caps and glaciers. But the total amount of all these resources is almost fixed and it is not much variable. The oceans are usually covering 97% of the water on Earth. Whatever water we have on Earth, out of that water, 97% is in the form of oceans, with an estimate of this 3,610 lakhs kilometer squares. Some amount is in atmospheres, that is just 0.001%, that is 5,100 lakhs kilometer squares. Rivers and streams are again in 0.0001 percentage. Groundwater approximately 0.31%, lakes 0.01%, ice caps and glaciers 2.15%. And the water that stays into these different types of water bodies also has an average residence time, the time for which it is usually staying at that particular in that form is the residence time of water. Oceans have the residence time of thousands of years. That means they can exist for numerous number of years. In atmosphere, the water stays just for 9 days. In rivers and streams for 2 weeks. Groundwater, it sustains for hundreds to many thousands of years. In the lakes, it is tens of years. And in ice caps and glaciers, again tens of thousands of years. So majorly it is more abundantly available and for a longer duration of time in oceans and in the ice caps and glaciers, and later to that it is available in the form of groundwater. So although we have a lot of water available on Earth, but the major problem is that we don't have sufficiently pure water that we can use directly. So that is a major issue for which we always keep on competing. Amount of water for which all people, animals and plants compete is less than 1%. So this figure is referring to the pure water that we have on Earth. We do not have sufficient amount of pure water, and for survival we need water in that pure condition. The pure water is usually less than 1%, because of which there is a lot of struggle, and definitely we need the water for survival. Now, what is the average amount of water that one person needs? So each person needs approximately 20 to 50 liters of safe fresh water per day, which is used usually for drinking, cooking and cleaning. So this is rather a modest figure. Actual figure goes much more beyond this particular limit. So this is the minimum which we require. At least 20 to 50 liters we require in one day for our survival. As per WHO and UNICEF guidelines, the data from these resources, 2.1 billion people, that is nearly 3 in 10 people worldwide, they do not have safe and readily available water at home, and 6 in 10, or rather 4.5 billion people, lack safely managed sanitation. So this is a scenario which was updated in 2017, which states that we have a big issue of clean water availability, that is for drinking, and also water that is available for us for the other uses, and as well as sanitation is also lacking. Now there are two terms which comes to those countries which are facing water crisis. One is the water stressed, the other is called water scarce regions. The water stressed are those countries or regions in which per capita availability is less than 1700 meter cube per year. So usually those areas where they do not get the water availability for one person, and usually that is less than 1700 meter cubes per year, that is annual availability is less per capita, that is called as the water stressed country. And wherever there is per capita water availability less than 1000 meter cubes, that is called the water scarce country. So scarcity basically means that there may be water unavailable due to various reasons. One can be physical shortage, that the water is not able to reach a particular region. So that might be the physical shortage, that in the surrounding area it is not available easily. The second, it may be because there might be failure of institutions regarding the proper supply of these water resources. They are not able to supply in a proper manner. The third thing, it may be due to lack of adequate infrastructure, that they do not have sufficient infrastructure for that particular water supply. These are the major reasons why at a particular area there is scarcity of water. Now, if you can observe, there are these, in this slide, there are different rankings. The yellow ranking is the low, medium baseline water stress countries. The orange is the medium high baseline water stress countries. The reddish is the high baseline water stress countries, and this particular darker color, more dark red, is the extremely high baseline water stress countries. I would like to know if you can find out where India is located from in all these categories.
Where can you find extremely high baseline water stress, madam?
Absolutely right, sir. May I know your good name, sir?
This is Professor M.A. Modi from Baroda, MS University.
Thank you, sir, for paying attention. So we find India over here. That is in extremely high baseline water stress countries. That means we are facing a major issue of water availability, water scarcity, water stress regions we have in India, and we have a backing of all these figures into that. So over 2 billion people live in countries experiencing high water stress. 700 million people worldwide are displaced or could be displaced because of this water scarcity by 2030. That is the projected scenario. It was projected in, it was rather predicted in 2013. About 4 billion people are representing nearly 2/3 of the world population, and they experience severe water scarcity at least 1 month of the year. A third of the world's biggest groundwater systems are already in distress, and nearly half of the global population are already living in potential water scarce areas. And majorly 73% of these affected people are found in Asia. So these are facts and figures. Water availability in India, coming to that. So an estimated annual potential precipitation is 4,000 billion cubic meters, and apart from that, some part of it is in the form of rivers, that is 1869 billion cubic meters, and some part again goes into some utilizable water, that is 1123 billion cubic meters. Out of this, we have 690 billion cubic meters as surface waters and 433 billion cubic meters as groundwaters. India is having the 17% of world's population. We all are very well known of this fact. And only 4% of world's renewable resources are there in India, with 2.4% of world's land area. So the water resource availability is uneven, because of which we are facing this water stress. 54% of India faces high to extremely high water stress. So these are red regions. The red regions which are marked into this particular map shows the region where water availability is very low. Water stressed areas, as we have earlier discussed, where per capita availability of water is less than 1000 meter cube per year. Those are basically the water stressed countries, and the red regions of India are denoted as the water extremely high to high water stress regions. So I think more than 54% of this India is into the water stress areas. So if you can observe this particular chart which is displayed on the screen, there are trends into different countries for water utilization in different sectors. Like the green sectors denote the agriculture, water use that is used in agriculture. The red sections denote those water requirement in industrial areas, and the blue in domestic areas. Can you find similar countries having the countries which are having similar trends rather? If you can point that out to me, anybody of the participants can.
India and Thailand.
Yes, very good. India and Thailand are similar. Any other country is similar?
Argentina and Australia.
Yes, Argentina and Australia is again similar. Any other countries?
Canada and
Sorry,
France.
yes, sir. That's nice. Canada and France. And Russia and US is similar.
Japan and Brazil also similar. Near about
Yes,
similar.
yes, sir. Absolutely right, sir. Thank you for all the participants who are responding and paying attention. So what is the basic trend which we are observing to this figure? That there are certain countries in which agricultural water requirement is relative, and some section is required for the industrial areas, some part is for the domestic areas. But when we compare it with Indian scenario, what we can find is that in India, the agricultural water requirement is much more as compared to those developed countries like USA, Russia, France, Argentina, rather Canada. Canada and Russia are having the highest water requirement in these industrial sectors and lesser water requirement in the agricultural sectors. But when we compare to India, we are majorly agrarian country, because of which we have a lot of water requirement and demand in the agricultural sector as compared to the domestic and industrial areas. So that is the major challenge which we are facing regarding water supply. What are the key issues for this water quantity management? Why we need to focus upon water quantity management? Reasons are various. One of the reasons are that we need to protect our resources. Why? Because there is deterioration of these resources. As the picture denotes in this particular slide, the rivers are drying at a much faster pace in the past decades as compared to the earlier times. And the right picture, we can observe that there is a river of Chennai named as the Puzal Lake. Sorry, rivers. Pardon me. That's a lake in Chennai, the Puzal Lake, that was observed, and within a year that dried up almost completely. So June 15, 2018, this is the picture. In April 6, 2019, it went on drying, and by June 15, 2019, that is within a span of 1 year, it has dried up almost completely. The second problem is that we need to protect the groundwater. Why? Because there is excessive drilling of bore wells. As the population is increasing, the requirement for water goes on increasing, and because we do not have an even access to the water resources, the only water resource which we have is the groundwater. So majorly in domestic areas, we rely upon these bore wells for a water supply. And because of this more number of bore wells which are being drilled these days, the groundwater level is going on decreasing. So according to a study that was taken up by the groundwater resources in India, the groundwater level is falling on in Tamil Nadu, it has decreased by 76%. In Punjab, it is by 72%, Kerala 71%, Karnataka 69%, Meghalaya 66%, Haryana 65%, Bengal 64%, and Delhi 62%. So there is a lot of fall in the groundwater level that has been happening in the past decade. Another issue is when we look at the water supply system, we are supplying, or whatever we are getting in our domestic areas is at a particular constant supply. Like this particular figure can help you understand that the darker blue line is for water demand, and the light blue line is for the water supply. When we have a look at the demand and the supply scenarios, then in that case we can make out that the water is being supplied at a constant rate. This particular line is almost constant, it is not varying a lot, but the demand is varying. So in India, that is the major issue, that the supply is at a constant rate. Certain times the demand is low and at certain times the demand is high. Because of which what happens, there is a lot of water loss. So when the demand is low, we are supplying in excess, and when the demand is high, we are supplying in below the requirement. Because of which there is a gap of the demand and supply which needs to be looked at so that we can manage the quantity of water which we have to our availability. And this particular picture, it's evident that certain places there is a lot of rainfall that is causing floods, and in certain places there is absolutely scarcity causing droughts. Because of this uneven water availability, the water is the major problem to be addressed in today's time. Then we have overconsumption of water in agricultural areas. There is no proper management for this cropping. And then regarding water quality, the water quality which is getting supplied is again the major issue, because our health is adversely impacted by the quality of water. So as we consume the water directly, we know that a lot of diseases are being caused, waterborne diseases are there that is hampering the health of people. And water quality is a major issue when it in regard to this the water supply systems. There's a lot of risk of contamination of sources of water. According to the United Nations, clean water, if there is proper supply of clean water, then itself that can reduce 21% of deaths. So if we have proper clean water available to everybody, then we can reduce the number of deaths that are being caused due to various types of waterborne diseases. And diarrhea is a major issue that is leading to illness and death in children below 5 years of age. Usually diarrhea is because of the contaminated water. Then we have lots of surface water pollution because of improper disposal of these waste, which is ultimately deteriorating the quality of water resources in the surface areas. We have been improving, we are focusing upon proper waste management. Still, we have a long way to go. As in the previous session, you might have you might have heard to Dr. Pawan Labhasitwar sir, who is the scientist at NEERI. He also pointed out that in 2017, he saw a water resource where there was contamination of algae contamination and arsenic contamination. So 2017 is not way back, just a few years back, where they found a lot of contamination into surface water bodies that was causing problem in the surrounding area. So although we are focusing a lot upon this water waste management, but still we need to focus more and we need to go a long way ahead. Then water quality, again, we have groundwater pollution. There are various types of elements that are being found in groundwaters. Majorly, these elements arise due to improper solid waste disposal. And because of this improper solid waste disposal, there are a lot of nutrients that percolate into the groundwater like nitrates, fluorides, iron, arsenics, leads, chromium, and cadmium. Not only solid waste, but also because of the industrial activities and improper disposal of this waste. I had performed a study in which I found out the treatment pattern of these sewage treatment plants, and what I studied is that all over India, only 60 to 70% of the wastewater which we are generating is being treated. That also is a modest figure. So on an average, only 60 to 70% of that wastewater which we generate is being treated and then disposed of. But the remaining 30% is again causing the pollution to spread up into the water, which we are discarding without treating. Then we need to think about different types of contaminants that are occurring in water. Different types of contaminants include pharmaceutical based compounds, pesticides, phthalates, a lot of chemicals which we are using into different products, like the daily use products which we are using, the human consumption products, cosmetics, and so on. A lot of things which we are using all add up to the contamination into the water. And another issue which we have in India is that there are too many organizations that are taking care of water, and we do not have one single specific organization that could take control of the quality and supply of water. Like the Central Water Commission is looking after the surface waters, Central Groundwater Board is looking about the groundwater, Indian Meteorological Department is taking care of the rainfall, Central Pollution Control Board looks about the water quality. Ministry of Agriculture and ICAR is regarding water use for agriculture. Department of Environments, Forests and Wildlife and Ministry of Environments and Forests all take care of the environmental impact assessment. Central Public Health and Environmental Engineering, which comes under the Ministry of Urban Development, will look about the water supply, sanitation and sewage disposal. Then there's Department of Power that will take care of the hydroelectric power that is basically using water for generating electricity. And the Departments of Forests takes care of the watershed management. So we have a number of regulating authorities and agencies that specifically address the water issues at different levels, and we do not have a single water governance authority that would take care in the whole of the water quality and supply related issues in India. So for every particular specific problem, we have to go to a different authority. Then what is the need of today? We need to have sustainable water management. Sustainable water management basically means that we need to focus upon the quality of water, and it should be used in such a way that the water quality should not degrade to the coming generation. The coming generation should have the same type of water quality which is available to us today. So for that, we need to focus upon this water pollution. And if at all we are creating some pollution or discarding some used water, it needs to be properly treated and then be disposed of into the different water bodies. That only will help in achieving the sustainable development, and the sustainable development addresses all three issues at one time, that is the economy, society as well as the environment. So sustainable term is very well known to all of us these days. The only thing is we need to focus upon sustainable use of these water resources such that it can also have proper water supply, it can meet the water demand, but at the same time those water resources quality should not be degrading. For that, we need to have water treatment, not only for supply but also after we use that water in particular functions or uses. After using that, we need to treat it and then we need to dispose it of. Water is required for various reasons, like for domestic purposes, drinking, washing, cooking and cleaning. Water is also required in industries. Various industries processes require ultra pure water. Pharmaceuticals and food processing industries have the independent set regulations for water purity that they require for processing. And after water is used in any of the areas, it gets loaded with a lot of contaminants. And these contaminants are in particular dangerous to both people as well as nature. So that is the major reason why we need to look into this water treatment agenda. Now, what are the emerging trends in wastewater treatment? So wastewater treatment these days, rather it's been evolving since a lot of time. When we look back 20 years back into the scenario, the trend has changed a lot. So presently there are majorly 5 types of techniques that are being used for wastewater treatment that perform efficiently. First is the membrane separation, second is the irradiation of photocatalysis, third is the nanoparticle treatment, fourth is bioaugmentation, and fifth is hybrid technology. So I will be giving you a rather overview of all these technologies and how they can aid into the wastewater treatment scenario. So first is the membrane separation technology. Now there are several options that are available these days. Different types of membranes are there that are used for treating this wastewater. Any of the membrane all involve the simple concept that the water is forced through a particular film that is made of microscopic holes of different sizes. Depending upon the sizes, they are having different nomenclatures, which we will be studying in the next slide. But whatever holes are there, they are of particular size through which water is forced out. The liquid passes through these holes, but the contaminants get stuck into these holes. That leads to the basic purification of water. A lot of innovations are there into these membrane development these days. On a broader scenario, we can classify these membrane as microfilters, ultrafilters, nanofilters, and reverse osmosis. So I think an overview was already included into Dr. Pawan Labhasitwar sir's lecture, but still we will be discussing this, that we can treat raw water or contaminated water by these different membrane techniques. All are named according to their different specific functions and the pore size of these membranes that can block specific type of contaminants. Like this microfilter, the membrane pore size ranges from 10 to 0.1 microns, and the water is usually passed at the pressure of 0.2 to 5 bars through these membranes. They can remove the contaminants to a considerable level, but still some amount of contaminants are retained into the water that passes through these membranes. Then the ultrafiltration pore size goes on decreasing, 0.1 to 0.01 microns. The membranes have these, the pore size of these 0.1 to 0.01 microns, and the water is passed with the pressure of 1 to 10 bars. Again, some relatively more contaminants are used, filtered out in ultrafiltration, but still some contaminants like the monovalent ions, divalent ions, and some molecular organic groups are retained into the water that is passing out of these ultrafilter units. Then a better performance is by nanofilters, in which the pore size further goes on decreasing, 0.01 to 0.001 microns, and the water is passed at the pressure of 5 to 10 bars. And the best performance is of reverse osmosis, in which the micron size of the pore size of filtration unit goes on further decreasing, 0.001 to 0.0001 microns. Water is passed at 10 to 150 bar pressure, and as the name suggests, reverse means it is flowing in the opposite direction, and with the help of which a lot of contaminants can be removed. 99.5% of pollutants get removed if we use reverse osmosis. But then we have a major disadvantage in reverse osmosis. If anybody knows that we use reverse osmosis into our water purification systems also at homes these days. If anybody could tell that what is the major disadvantage of this reverse osmosis. So anybody of the participants, if they know that reverse
Rejected
osmosis,
water. 1/3 of 2/3 of rejected water output, madam.
that's right, sir. May I know your name, sir?
Venkatraman.
That's absolutely right, sir. Thank you so much for responding. So one disadvantage is that a lot of water is rejected, and the other thing is, as far as I know, that we need some minerals for our metabolism. Whatever water we drink, we need some amount of minerals that is required in our metabolism, like the calcium and magnesium. This type of compounds are necessary for our proper metabolism. But if they get removed completely, then what will happen? If we are drinking water which is devoid of minerals, then what would happen? Can anybody tell?
Pardon, ma'am?
If we consume water that has no minerals at all, or the required basic nutrients like the calcium and magnesium which we require, if we do not have that into the water which we drink, then what will happen? So what will happen if we drink a water that doesn't have required minerals and essential nutrients? Then in that case, our metabolism will be hampered. So that is why whatever water we drink, some amount of minerals should be there, and the water which is generating from this reverse osmosis is completely devoid of these minerals. It removes all things, because of which there are health effects. So reverse osmosis water is not that much beneficial to human metabolism as compared to other processes. So I hope an overview of this particular different membrane technologies is clear to you. And there are different applications in which wastewater is treated using these different types of membranes. Like the ultrafiltered membranes can treat this vegetable oil factory wastewater. The results study has showed, one of the studies has showed that COD can be removed to 91%, TSS to 100%, TOC to 87%, phosphates 85%, and fluoride 40% could be removed by using ultrafilters. Similarly, MF as the microfilters, RO is the reverse osmosis, NF is the nanofilters, and so on. So microfiltrations are successful in treating urban wastewaters that can remove pesticides and pharmaceuticals. Microfilters again can remove contaminants from municipal wastewaters, synthetic emulsified oily wastewaters. Nanofilters are successful in treating dump site leachate wastewaters. Ultrafilters are treating poultry slaughterhouse wastewaters. Nanofilters can treat textile wastewaters. Metal finishing industrial wastewaters can be treated oily wastewaters, and phenolic wastewaters from paper mill. So a lot of studies are there in which successfully removal of contaminants are there using these different types of membrane filters like the ultrafilters, microfilters, and nanofilters. But the latest generation is of the graphene based membranes. So if you want to follow up a study that was given by CSIRO Sydney, Australia in 2018, and they state that graphene is the water filter of the future. Now, basically, I don't know whether you were well aware of this particular compound or not. Graphene are carbon chain sort of sheets, single plane sheets that can be used, that are used in different areas these days. And one of the applications is the water treatment that is can be well explored, and probably the coming future generation filters will be based upon these graphene membrane filters. Graphene has been used in successfully used in different types of purifications like the water purification, desalination, metal ion removal, gas separation, and water purification. So these are successful graphene oxide based membranes that are currently being explored for the wastewater treatment, not only the different types of wastewater but also for ions and salt content removal from water. Irradiation and photocatalysis is a popular purification solution these days. Uh, the basic principle is that we expose the wastewater to radiation. That radiation can be either visible, UV, gamma, different sources of radiations are there. If water is irradiated with a specific source of light, of radiation rather, and if we have some photocatalytic catalytic substance or substance which acts as the catalyst in the presence of these radiations, then it helps in the degradation of that pollutant, and ultimately the byproduct end products that come out are lesser harmful. Specifically, see, these technologies are useful in treating waters with different types of hormones and antibiotics. In certain cases, almost 100% effectiveness is observed in removing pollutants from wastewater. So basic idea in this particular chart is that if there is a UV light source and if it is irradiated to a catalyst like the TiO2, then in that case, upon getting irradiated by this light, it generates radical species. Specifically in this case, hydroxyl radicals are generated. These hydroxyl radicals are highly oxidizing agents. Then they attack the pollutant molecule or species, Then ultimately they break it down, disintegrate that substance into lesser harmful substances and convert it into water and carbon dioxide. So this is a basic principle of what is happening in a photocatalytic oxidation process. Now this catalyst can be any type of substance that can be reactive to this particular light that is exposed to it. So TiO2 is most commonly used. Other than that, there are varying species that are used like the NN2O5, SNO2, WO3, Fe2O3, IN2O3, BiVO, and so on. So a lot of silver doped graphene oxide and titanium nanotubes are also used these days. And there was a water filter that was designed by Panasonic in 2014, and it released it on a commercial basis, in which it used water with sunlight and photocatalyst. So using sunlight as the source, they designed a water filter that could be used for treating water. Then during my tenure at NIRI, I had also performed a work that was regarding the advanced oxidation process, in which we had used TiO2 for treating wastewater from a particular treatment plant that was coming from Ankleshwar, Gujarat. I would encourage you to go through this particular matter. That time we didn't used to have everything online, so rather it would be a hard copy of this particular article which I have. The basic highlights are UV and UV TiO2 was used to treat the organic pollutant load into the wastewater which we selected from the particular site, that is from Ankleshwar, Gujarat, and we successfully treated the water with this advanced oxidation process, in which UV TiO2 performed in a much better way as compared to simply UV or simply TiO2 which was used to treat this water. The combination worked effectively. COD was removed 79% in 15 minutes of time with TiO2 as the catalyst load at the load of 0.067 grams per liter of TiO2. So this is approximately a decade back study which we had performed that time, and that time advanced oxidation process was relatively new field to be explored. Nanoparticle treatment is becoming ever increasing option these days. Nanotechnology is used in the form of membranes. It is used for adsorption, as photocatalyst, as for disinfection and microbial control, and as sensing and monitoring. So nanotechnology, we know that as the size goes on in decreasing, that's the time when we call it at a nano scale. So the objects that are usually smaller than 100 nanometers come into the nano scale. These nanoparticles can be used to absorb pollutants, and as well as they can be used to remove them from the water. The basic idea is, in earlier days we used to use charcoal or we used to use activated carbon for the removal of these pollutants. The similar process can be done at the nano scale, at the nano level, in which nanotubes are made of absorbent material like carbon, but the size is reduced to the nano level. That causes significant and effective removal of pollutants from water. So this technology is rather relatively expensive, because of which it is not becoming that much commercially available, but still devoted to the scientific exploration which is going on, we hope that it will become more affordable and viable in the coming future. Then there are nanomembranes, basically small sized particles that are layered into these membranes, and that can effectively treat wastewater, like there are platinum, gold, iron, titanium based membranes that will be effective in removal of or treating the contaminated water. Adsorption is another technology that can be used for treating this wastewater, the water that is polluted with different contaminants like the heavy metals, dyes, organic compounds. If they are treated with the adsorption process, adsorption can be chemical, physical, or biological. That depends upon the type of adsorbent we are using. Then in that case, there can be successful removal of these contaminants from the wastewater. Again, some similar work I had done that was published in 2014, and I tried to remove toxic phenol from water using wheat husk. Then wheat husk is basically a agricultural byproduct that is discarded, that was used for this study, and we successfully treated the water that was phenol contaminated water, and we could remove it up to about 91% using 3 grams of wheat husk. And that the removal basically depended upon various factors like the phenol concentration, adsorbent dose, and pH. But still, at an optimized level, we could find out 91% of phenol removal using this wheat husk. I would again like to encourage you to go through this article. This is an open access article. You can find it out on the Google platform. Then nanocomposite for wastewater treatment are successfully being used these days. One of the study is by Waterloo Engineering in 2014. They developed a novel approach that could treat organic contamination that is coming from petroleum processing plants, and they used a photocatalytic titanium dioxide along with magnetic iron oxide. So they rather innovated a nanocomposite that could not only treat the oily pollution that is coming from these petroleum processing plants, that are basically hydrocarbon based compounds, and a major issue that is in the coastal regions where they want to discard the wastewater. Not only that, high volumes of water they treated, and along with that, this nanocomposite could be recovered because it was magnetic iron oxide based. As they activated a magnetic field around this nanoparticles, nanocomposite, they could recover that nanocomposite as well. So not only that was treating the wastewater, but also the it was rather cost-effective solution in which this magnetic iron oxide could be reused n number of times. So this is a very inspiring case study which you can go through over the internet. That is the Waterloo Engineering, in which they treated the petroleum processing plant wastewater using this photocatalytic titanium dioxide and magnetic iron oxide nanocomposites. Now these days we have nanotech biosensors. These biosensors basically indicate the pollutants that are present in the water. They are low cost and easy to use biosensors. They just give an idea about the presence of particular contaminants. And these nanoparticles that are used into these sensors attract metals and pesticides, and they're also helpful in removing them from the water. So one of the studies had developed a bacterial biosensor in which they could sense the presence of toxic mercury, lead, cadmium, and gold ions into the water samples, and that could assist in the effective treatment of these heavy metals that are present in the particular water sources. Excuse me. Another option we have bioaugmentation. So what is bioaugmentation? Is basically that when we use microorganisms for treating the wastewater, then in that case it is called as bioaugmentation. Rather, it is not a relatively new technique. Earlier times also we used to treat wastewater with the help of activated sludge process or trickling filters, if you might have heard that. So these are basic units which are used for treating wastewaters. But what is the change into this is that when we specify the microorganisms that are required for degrading a specific type of compound, then it is called as the bioaugmentation. We increase that particular microorganisms into a wastewater that helps in degrading a specific type of pollutant. So microorganisms have the ability to naturally degrade pollutants like oils and carbon substrate. If specified pollutant needs to be removed, then in that case this technique is very much helpful in aiding to the decomposition process of these organic based compounds. So this process releases nutrients as a byproduct and makes water healthier rather as compared to the other processes in which byproducts were released, maybe chemical or other substances based, that could have a potential of contaminating the water. So what's the basic advantage? That these microorganisms release nutrients and that would make the water much healthier as compared to the other techniques. So the basic idea is that if we have a treatment tank into which wastewater is coming, and then we increase the number of microorganisms that degrade specific type of compound, like in this case the study, they have increased the nitrogen removal bacteria that specifically focus on attack on the nitrogen based compounds. Then in that case, we have significant removal, improved community of these bacteria leads to a significant enhanced efficient quality, effluent quality, and because of this process, the efficiency of the process keeps on increasing. Then latest in the latest literature, a lot of studies are being performed these days. This is the current area of research in which bio-augmentation can be used for treating different types of wastewaters, like the distillery wastewater, municipal wastewater, seafood processing wastewater, paper industry wastewater, tannery, textile, and aquaculture wastewater. So you can find these articles, which are, this is the latest scenario in which a lot of work is being done on bio-augmentation for treating different types of wastewaters. So what is new in this particular technology? With the help of biotechnology, we can enhance the specific type of microorganisms that are required for degrading a particular type of pollutant. So because of this biotechnology, we can make it tailor-made depending upon the requirement, and different combinations can be used that would rather help in degrading the specific type of pollutant.
Chat box में question. What is PSN, PCN?
Yes, I think there's a question in the chat box. PCN is phosphorus, carbon, and nitrogen removal. Okay. Sorry, let's go back. So bioaugmentation has the basic advantage that it enhances the ability of microbial communities to degrade organic substances in wastewater. It increases the capacities and organic conversion rates. Also, enhanced flock formation and settling characteristics can be achieved that ultimately leads to decreasing COD and BOD levels. And this particular technology, that is the bioaugmentation, responds much more effectively to the load and flow. It also improves the plant's performance and decreases our reliance on dewatering chemicals like the polymers and flocculants and other chemical compounds. So because of this bioaugmentation, which can be tailor-made according to the situation, according to the pollutants that we have in wastewater, we can specifically design it according to our requirement, and ultimately when we add the microorganisms that target specific type of compounds, then that pollutant can be effectively removed using this bioaugmentation technology. And the last is the hybrid technology. So in hybrid technology, as the name suggests, some two techniques are used in combination. That is why it is called as hybrid technology. Mostly, we have the membrane technology combined with the bioaugmentation that leads to a better performance of this waste removal from the water. Membrane bioreactors are specific examples of this technology, which are effectively and efficiently used to remove contaminants, and these are becoming increasingly widespread these days. Membrane bioreactors are basically this is a single sort of treatment device, but with two compartments. In one compartment, there is a bioreactor. Bioreactor is basically the area that I would like to go to the figure. So in this particular unit, that it is separated into two parts. One is the bioreactor, the other is a membrane. So in the bioreactor part, the organic pollutants get attacked by the microorganisms. These microorganisms consume or degrade it into a lesser harmful substances, and ultimately contaminants are forced to pass through these membranes. These membranes block not only the microorganisms but also pollutants along with them, and ultimately clean water can be achieved. So membrane bioreactors are the simplest and the most commonly used examples of this hybrid technology that can effectively produce high quality of water. So this is another figure in which after the treatment of microorganisms, the water is passed through different types of membrane, and that leads to a relatively high purity water as compared to the other options. So if you can observe the figure over here, in the upper figure is the usual treatment pattern which we adopt for treating wastewaters. Like the water is passed through a solid removal unit, then it is passing through a pre-treatment unit, then aeration zone, then settlers, then finally sand filtration and disinfection. But if we modify it at this level, if we use a membrane bioreactor, then in that case, can you observe any differences that are happening into the technology, or rather the sequence of the technological treatment? Can anybody observe and respond? So what is the basic difference if we change this to a membrane biofilter, bioreactor rather? If anybody could point out. If we use this hybrid technology, that is the membrane bioreactor technology, then it is the up-to-date technology for wastewater treatment. Why we are telling it as up-to-date? Because if we use this membrane bioreactor, then this single unit can serve the purpose of filtration as well as decomposition of these organic compounds. And after passing through this unit, we can dispose the effluent, as compared to the earlier scenario in which we used to require a more number of units that we, after settling, we used to pass it through sand filtration and then disinfection, and then only we were able to discard it. But if we use this membrane bioreactors, then in that case, this single unit serves the purpose of sufficient treatment of these pollutants, and we can discard it after passing through this particular unit. So it not only saves time, it also decreases the area that is required for treatment, and the water purity is also sufficient. Because of which this hybrid technology is much more effective in generating high purity water. So there are certain advantages of this membrane bioreactors. It operates in a trouble-free manner. It has a modular design. It can be automated. It also saves 50% of occupying area, as we have seen in the figure, previous figure of the slide. 50% area can be reduced. The MLSS value is relatively high, but still it is less than 15 grams per liter. The residual time for sludge is long, but less than 60 days. The sludge residue decreases, because of which the cost of the sludge treatment also reduces. There is low consumption of energy, operational cost also decreases, and cleaning is rather simple. Because of which this membrane bioreactor is an evolving technology these days. Where can we apply these membrane bioreactors? There are various areas like the sewage treatments can use it, wastewater treatment plant in any industries can use this technology, Restaurants, hotel, hospitals, sanitariums can use this technology. Villages, towns, and home communities can also utilize it. Troops, scenic spots, mines, factories, airports, harbors, stations, and so on. So there is an unending list of areas where we can exploit this technology for getting sufficiently pure waters. And there is a latest research that is going on regarding the membranes that can be used into these bioreactors. Rather, nano membranes are proving to be more efficient. The nanomembranes made of different types of nano substances like the nanofibers, NFs are nanofibers, NPs are nanoparticles, nanotubes, nanocrystals, nanowires, and nanosolids. Sorry, nanosheets. So, a number of nano-based membranes that are more effective, and rather in recent times a lot more studies being evolved regarding these nano-based membranes that are effectively removing the pollutants into these membrane bioreactors. So coming to the last point of this presentation, what did we understand from such a lot of talk? That we need to improve wastewater treatment, and wastewater treatment is an ever evolving process. So if we look to the previous times and compared to times today, we are still working upon wastewater treatment, we are still evolving, we are still innovating, and it will be an ever evolving process because the pollutants that are coming into wastewater are changing day by day. So for that, we need to keep this wastewater treatment up to date so that we can efficiently treat the water and then discard it into the different sources of water. Water usage definitely produces a lot of harmful pollutants. Water is used in different areas, domestic, industrials, and a lot of power production areas, research areas. Everywhere water is used, and wherever water is used, it is leading to a lot of contaminant load. There are companies that can recycle, and if they recycle this water, that will help in saving their money. These modern purification methods are useful. They help in achieving the level of purity that is required in water. And if we keep on recycling water into different areas, wherever water is used, if we try to recycle it, then we can reduce the amount of waste that is generated and also protect the environment. So it is really essential that we treat the water before discarding it. We try to make it a decentralized treatment area, and if we keep on using the resources, then it is our responsibility to maintain the resources in that particular natural way only. So that's from my side. I thank you all for your patient listening. If you have any questions, doubt, if you would like to interact, you're most welcome. Yes, Milind Pandit. Uh, Actually, I was discussing regarding the emerging trends. So, sand filter, a very well established technique that is being used in the water supply area. But what I was focusing was that how we can treat wastewater. So that is why I didn't focus a lot upon the sand filter. Anybody else? I hope my voice was audible, my PowerPoint was visible, and you could understand, at least make out some part of the presentation.
Thank you, ma'am, for wonderful session in which ma'am described scenario of water globally, ranking of water availability, global water uses in various sectors, key issues in water quality management, emerging trends, and ma'am research case study of Gujarat and nanotechnology. So thank you, ma'am, for wonderful session. Thank you, participants. We'll meet tomorrow. day 5 for our STTP. So thank you very much, all participants. Feedback link will be shared in WhatsApp group within 5 minutes. Thank you very much.
Thank you so much to all the participants, and thank you so much, Lalitesh sir. And we hope to meet you again tomorrow at 10:30 a.m.
Thank you, madam. Thank you very much. It was very
Thank you,
nice
sir.
presentation.
Thank you so much, sir.